Very good morning and very good afternoon. Please confirm whether I'm loud, audible, and clear or not. Please let me know. Simply raise your hand or mention in the chat section to confirm if I'm audible. Okay, great. So basically, today our session was scheduled from 9 p.m. 9 a.m. as per Indian Standard Time, but due to some technical glitch, we were facing some kind of technical glitch with the system as well as with the server, due to which we were not able to start the session on the scheduled time, right? And I have received a few queries. Some of you are raised on tickets on through messages, right? About the session. So this was the reason that's why we were unable to start the session on the scheduled time, right? But after solving all the technical issues and the problem that we are facing, now we are starting the session at 10 a.m. as per Indian Standard Time. So now the schedule of the session is from 10 a.m. in 10 a.m. to 1 p.m. as per Indian Standard Time, right? Okay. Okay, so before starting the session, please let me know uh, whether you have revised all the concepts, okay, all the concepts or the modules related to data science, which is covered by your institute or not. Yes, I'm fine. I hope you are also doing well. Okay, I was in hurry because we were facing some technical issues. That's why now we are in hurry, right? So I'm really sorry for that. That you are because you are waiting from a very long time to start the session, right? Okay, we have revised the things which were covered till now. Okay, good morning, sir. Sir, not revised properly. Okay. That's fine. Okay, sir, not revised properly. Okay. Okay, not revised properly, revised but little hard to remember all points. Okay, good morning. I revised 75%. Okay, someone is saying that I have not revised. Sir, we will be discussing the project today. Yeah, we are going to discuss a project, okay, related to machine learning. Okay, not revised properly. Okay, those who are saying not not revised properly, so can you please let me know which modules have you revised till date? Okay, someone is saying machine learning not revised and revised till data wrangling and visualization. So basically, you have covered only 20% or 30% of your data science modules, right? Because there are only as per your institute has informed, right? As per your the information shared by them, they have covered basic stats with Excel. Then after that, they have covered maths, SQL, I think some programming foundation. And then after that, they started Python, where they have covered NumPy, Pandas, right? And they have also covered some visualization libraries like Seaborn and the Matplotlib, right? Then after that, they have covered machine learning, right? Along with advanced stats, right? Okay. So, okay, except the topic SBM, I have revised everything. The mathematics of SBM is a bit hard. Okay, that's fine. Basically, if you are learning about any machine learning algorithm, so instead of focusing on the theory part, you should focus on the mathematical part because the mathematics is the real the real thing that is working behind any algorithm, right? So if you are not If you are only focusing on the theoretical part, then it may be difficult for you to understand the working of any particular library or any particular algorithm. Okay, someone is saying I am weak. Okay, someone is saying revise to programming foundation. So I think you should say that you have just started revising the concepts of data science module, right? Because you are saying revise till programming foundation. So as per their information, programming foundation was, I think, their second or third module. So before that, they have covered, I think, basic stats, right? So you have just started, right? Okay. Someone is saying I'm weak in machine learning and rest all modules are all right for me. Will practice, I will be okay. That's fine. See, those who are saying, sir, I'm revising. Revising means most of you are saying I'm watching recorded video. I have not watched the recorded video, something like that, right? See, first of all, you need to understand that whenever you are, when I'm asking about the revising, right? Whether you are revising the concepts or any particular modules, then the revising means you are practicing the same concepts in the related tool. For example, if you are using SQL Server for MySQL or for SQL language, right, or for MongoDB language, then it means you have practiced the concepts, the methods of that particular module in the specific tools. If I'm talking about Python, it means you have practiced all the things like list, Python, then dictionary sets, right? Other modules, functions, OOPS concept, like means object oriented programming concepts. Then after that, you have also covered the libraries like pandas and the NumPy, right? And revising means you are writing, okay, you are practicing the same concept by writing, by practicing in the related tools, right? Because watching the recorded video will not be helpful, because if you are just watching the recorded video on YouTube or another platform, or you are just attending the session, then you may find easy to learn about the theoretical part, and you may find easy, and you can imagine that, okay, just because I'm able to grasp everything, then I will be able to perform any operation. Okay, I will be able to write any code. But that is not the case here. Why? Because that, why this is not the case? Because whenever you are writing any code, right, whenever you are creating your logic, you are building your solution for any problem statement, at that time, if you are not able, if you have not practiced, then you may face difficulty with the syntax. Or if you are facing any kind of issues or any kind of error, then you will not be able to solve those errors. Why? Because if I'm writing a code, I am writing a code, right? Then definitely I have experience. I have experience means I have a good knowledge about that particular concept, right? So I'm not going to make the errors. I'm not going to make any mistakes. If I'm making mistake, then the mistakes will be minor. But when you are in a learning phase, right, then at that time you will face different kind of issues, like you are missing dots, you are writing something in capital letter, like, Python is a case sensitive language, right? And here the dot or any particular point, anything that is written in the coding has different meaning, right? So that's why I always suggest to use the programming language by writing, like, to practice the concepts by writing in the specific tools. Clear? Okay. And okay, someone is saying where we can practice, and they have good explanation for any errors. See, basically, if you want everything uh, at one single point, then that is basically quite impossible, right? If you want to practice the codes for SQL, for Python, then you can visit different websites like HackerRank, HackerEarth, CodeChef, right? There are so many websites. Code Wars are there. There are so many websites are there. You can register yourself there. You can solve as many questions as you can. But if you are asking about the error, then you have to search on the internet, because internet is a like you can say is a boon, right? If you are facing any kind of errors, then you can go through the internet. You will see so many answers. Some maybe may solve your problem, but some may not. right? But you are going to learn so many concepts from other, because I think you should learn from others experience instead of experiencing everything from you, right? Because if you are trying to experience everything, then definitely you may face different kind of complexities, as well as it will be a time consuming task, right? So someone is saying Stack Overflow. Yes, Stack Overflow is one of the website that is basically being used by most of the coders to solve the problem, because this is a community platform where everyone is sharing their solution for any particular problem they are facing, right? But in the even on the Stack Overflow, you may not face the exact, so you may not find the exact solution, right? So you have to check at different sources. You have to use all the methods by using your knowledge, so that you can solve the problems. Clear? Okay. ChatGPT is also very helpful when it comes to finding error. Okay, so you are saying you are using AI tools. See, using AI tool is a good option, but the problem is that ChatGPT is not accurate. Okay, even the founders of the ChatGPT, they have mentioned that the ChatGPT is the ChatGPT always not giving the correct answers, especially in case of coding. Okay, because the problem is that in the coding part, in the IT sector, there is no single solution for any problem statement, and as I mentioned that there is a specific meaning for each and every point mentioned in the coding part, right? So you may check on the chat gpt and you may find the solution, but in reality, whenever you are writing the answer, you are getting like, for example, you are giving an exam. Okay, I am conducting an exam and you are using a chat gpt. I have given some question and you just put there and you got the solution and you are sharing, but I am sharing the wrong solution. Why? Because the solution may not be correct. Chat gpt is basically using the pre-processed data, right? The you can say the uh, older data, right? They are also using different techniques so that they can get the give result. But if you are expecting that they are giving 100% accurate result, then that is not the case. Okay, so do not rely completely on the AI tools, because if you are relying on the AI tools and you are attending an interview, then the interviewer will not give you a chance to use the AI tools to give the answers asked by them, right? If you have the knowledge, then you do not need to use any AI tools or any websites to solve any kind of problem statement. And companies are going to hire only those techies, or you can say those who have a very uh, good knowledge, right, in the same field. Okay, so so basically it was all about a different kind of things. Right now we are starting the session, right? So this session is basically purely dedicated about how to work on machine learning, supervised machine learning project. Like you have learned, your company or your institute has informed that they have covered the different modules separately, right? But I hope they have not used all the concept together to complete any particular project. Am I right? Please let me know. Great. Okay. So before starting the project, please let me know what is the most important thing while doing any machine learning project or any coding based problem statement, right? For example, I am giving you exam, or you are working on any machine learning project, then what is the most important thing? I am giving four options. First one is your libraries, second one is algorithm, third one is the data, and the fourth one is the problem statement. Which is the most important thing uh, to work on any coding part or to work on any project? Okay, most of you are saying data. Okay, data pre-processing, data, clean the data. Okay, understanding the data. Okay, someone is saying problem statement. Okay, those who are saying data. Okay, someone is saying algorithm as well. Okay, someone is saying libraries. That's correct. Okay, those who are saying data, can you please let me know why the data is the most important thing? Second thing is those who are saying problem statement, please let me know why the problem statement is the most important thing. Those who are saying algorithm or the library, please let me know why the algorithm or the libraries are the most important thing. Okay, someone is saying because ML needs data to train. Okay, because we are going to work on it. Mhm. Okay, any another answer? Okay, because okay, without data, we do not have any problem or need of any library. Okay, data tells the story, what model to use. Okay, after understanding the problem statement on behalf of that, we can, okay, we need a clean data with minimal, okay, with minimal residual. That is why data pre-processing is important to gain insight and pattern from the data. If you want to work on machine learning problem, data is prime. If you don't understand the problem statement, then after that you will work on data or coding, okay, without raw material problem statement. Okay, because without data we cannot identify the problem. They can, then you want, okay, with a clear and concise problem statement we can proceed. Okay, because algorithm decide how the problem should be solved. Until we understand the problem statement in detail, we will not select the right data. Those who are saying the problem statement, their answers are correct, but those who are saying the problem statement, those who are saying, sorry, those who are saying data, libraries or algorithms, right, their answers are correct, but I am asking for the most important thing. Okay, someone is saying data pre-processing is important, someone is saying clean data is important, someone is saying data is important because without data, data is prime, we cannot do that, we are training the model, right? That's correct, right? But please let me know how you are going to identify whether any given data is correct or not, whether any particular given data is useful for you or not, whether any given particular data will solve the problem that you are facing or not. How will you identify? And most important thing, in the last weeks you have learned about the web scraping, right? So in the web scraping part, what you were doing, basically we were you were scraping the data, right, from the website. So how did you decide which data should be scrapped and which should not? Hmm? Basically you were scrapping the data based on the problem statement, right? If I'm asking, if you are writing the code, normal question, let it be about the machine learning, about the web scraping, I am asking about only simple code. If you are writing a code, say you are writing a code based on the problem statement, or you are first writing a code, then after that you are creating a problem statement. You are writing the codes based on the problem statement, right? Means problem statement means your question that needs to be solved, right? So if we are saying what is the most important thing in the IT sector, in the data science field, then that is the problem statement. Because if you are working on a problem statement that is basically related to the medical domain, and I am giving you the data related to a retail store, a retail data, right, then that is not useful. So if the problem statement is there, then you will get a clear picture about everything, because based on the problem statement you will decide what is the data, what is the correct data, right? Based on the problem statement you are going to decide what you need to do, what you need to achieve in the problem, in the given task, what do you need to solve, what is the problem that your client or any company is facing, right? What is your target variable, and based on the target, You are deciding different factors. You are deciding about which algorithm should be used to solve any particular problem statement. For example, if it's a classification problem, right? Then first I have to identify, right? First of all, I have to read the problem statement. I need to understand that, okay, what is the data here? What I need to do, whether it's a regression problem or it's a classification problem. If it's a regression problem, right, which algorithms should be used? We are deciding based on that, right? So the most important thing is problem statement. If you are able to understand the problem statement, then it means you have already solved the 80% of the problem, right? Because whatever doing, I'm creating a model with 95% of accuracy, but that is not related with my problem statement. That is not solving the problems that is giving in my task, then that has no use. Okay, so first of all, you should understand, you should read the problem statement several times, because sometimes it can be straightforward, sometimes it can be tricky one, right? So you need to read the problem statement several times so that you can know about the exact problem or exact thing that you need to achieve. Then after that, check the data. Based on the data, then after that, decide the libraries that you are going to use. Then after that, decide the visualization techniques that you are going to use to perform the analysis, right? Based on the analysis, build the model. Sorry, based on the analysis, make your decisions, right? Because see, machine learning is all about the hit and trial. If I'm saying the exact set of instructions, exact set of steps will solve the problem, then that is not the case. We are using the hit and trial method here. Means we are using a set of steps, we are building the model, we are checking the performance of the model. If the performance of the model is not correct or not in our acceptable range, then we are making changes in the set of steps. We are removing some of them, we are modifying, we are adding, we are again doing the analysis, we are changing our decisions based on our observation, right? So there is no unique solution, right, for any problem statement in field of in domain of IT, right? But the problem is that it doesn't mean that whatever you are doing is correct, right? Because if you are using any particular, you are using a scatter plot and you are saying that it is giving the count of the data, then that is not the correct, right? So first of all, you need to understand about the problem statement. Okay. Yeah, you can only hear audio because I have not shared the screen yet. Okay, so please wait for some time, then after that I will share my screen. Okay. Okay, second thing, I have observed that some of you are not submitting the task on time, right? So first of all, let me tell you more about the project phase, because from today onwards we are starting the project phase for your batch, right? In the project phase, there are two phases. First one is practice project phase and second one is project evaluation phase. Clear? First, I'm going to conduct a project discussion session today. Then after next is on next Sunday, right? After conducting the today's session, I will give you 1 week to revise all the concept, because some of you are saying that I have just started, some of you are saying 50% is done, some of you are saying 75% is done. That's fine, right? So today I'm going to conduct a session, then after that I will share the recorded video of this session with your institute and they will upload on their forum, okay, whatever the forum they are using. So you can go through the recorded video. You can practice the same project that I'm doing today. Okay, I will share the link of the data. Okay, you have whole 1 week to practice everything. Then after that, next Sunday I will conduct one more session. We will discuss one more problem statement. After that, I will give you around 4 or 5 days to again revise everything that I have discussed in the session, as well as what is covered in your by your institute. Then after that, after 4 to 5 days, we will start the project practice phase for your batch. In the project practice phase, we will give you some projects, okay, related to machine learning, where you need to do all the pre-processing, visualization, right, feature engineering, feature selection method. You need to build the models, right? You need to do so many things. Means you need to create a model and you need to check the performance of the model to solve that particular problem statement. During the project practice phase, we will help you. Okay, your SME, other teams, me. Okay, we will help you with the approach to solve any problem that you are facing while working on the projects, right? And during the project practice phase, we will give you around 8 to 10 projects based on the time limit, okay, given by us, because some of you are expecting a deadline, something like that, right? They are facing some kind of issues. So based on that, we will give you projects in range from 6 to 10 based on the time slot, okay? Then after that, after the project practice phase, we will start the project evaluation phase. During the project evaluation phase, I am not, just wait a minute, okay? Mr. Navaldeep Reel, okay? I have mentioned twice, like I have not shared the screen yet. I don't know whether you are paying attention on the session, whether you are able to hear me, okay? Because I don't want to repeat the same things, right? You are asking a very stupid question. I'm clearly saying, when I have clearly mentioned that I have not shared the screen yet, and I'm giving some instructions. So you, instead of focusing on that instruction, you are asking whether you have shared the audio or not, whether you have shared the video or not. First, focus what I'm saying, right? You have not given a single answer for any question, but you are worried about the video part. So wait for some time, right? I have just, when I have already answered your question, like I have not shared the screen yet, and I'm giving the instruction, then focus on that. Otherwise, I know you will come during the project practice phase and you will ask for the solution for any problem that you are facing, and we will deny it. So first, pay attention what I'm saying. Okay. Okay, sorry. Now, during the project evaluation phase, again we will give the project, but during the project evaluation phase we will not help you with anything, okay? Even your institute will also not help you with any question, because we have an agreement, and during the evaluation phase, because of our agreement, their team or your institute will not help you with any code syntax error or any kind of problem state, any kind of problem or anything that is used, that will be used in your project. Okay, so you have the whole project practice phase to ask the questions, to get the solution. Get the solution means to get the approach to solve the problem that you are facing. Okay, but during the project evaluation phase we will not help you with anything. Okay, so please use the project practice phase, okay, to learn more about the machine learning. Clear? One more thing, whenever we are giving the problem statement, whenever we are giving the project, we are also giving some instructions like how to solve the project, right? What should be done, right? How to submit the files, where you need to submit the files. So please, before starting the projects, please read the instructions. Okay, please read the instructions very carefully and complete your task based on the given instructions. In the instructions, we will give you the name of the project, we will give you the details of the project, like what is the problem statement, what is the features, what is the data, right? Also, we will mention about the deadline, and you need to submit the projects on or before the deadline. We will not give any extension, okay, under any circumstances. Okay, so please do not ask for any extension during the project phase. Okay, third thing, during the project phase, like for example, your deadline is 10th of March. For example, for to submit any particular project, today is your deadline. If you have submitted the project today, right? So within 5 to 8 days after the deadline, we will provide the feedback for your submitted project. Okay, for your submitted project. If you have not submitted, then you will not receive any feedback. If you have submitted the project, then we will give you the feedback. In the feedback, we will let you know where you are lagging. Okay, it will be basically generalized, because if you are mentioning about the EDA, then you should know what is missed in EDA, what more you can do, right? We will give you the feedback along with the scores for different parameters. Clear? And these feedback, right, you can receive. If you are not receiving the feedback within 5 to 8 days, maximum limit is 8 days, right? Within 8 days, if you are not receiving the feedback, then you can connect with your SME. Your SME will provide the feedback for all the submitted projects. Clear? So you need to connect with your SME if you are not receiving the feedback of submitted projects within 8 days after the deadline. Clear? Okay. So this is all about the instructions. Okay, now I am sharing my screen. Please let me know whether my screen is visible or not. Okay, one more thing. Whenever you are submitting your project, please make sure to submit the Jupyter notebook, that is IPYNB file. Do not submit the file in any other format like PDF, WordPad, or Python file. Okay, please do not submit in these formats. We are accepting the projects only in the IPYNB format, that is Jupyter notebook. Okay. Sir, apologies for interrupting. Can you tell us on what basis we will be evaluated and what will be the parameter? Parameter will be basically technical parameters, right? And whenever we are mentioning about the technical parameter, then there will be one parameter for the EDA. Okay, that is basically whole EDA. Then after that, one parameter will be for your accuracy, means about your performance parameter. One will be based on the errors that you are getting, right? Then one parameter will be based for whether you what approaches you are using to maximize or to increase the performance of the model. One will be for your efforts, right? So like there may be more than that parameters. So whenever we are giving the feedback, we let you know about the parameters. Okay, for each parameter what is the maximum marks and what score basically you have received, right? You have scored. So basically we will give you the detailed feedback, so do not worry about the feedback and the parameter. You will get know about all the parameters when your SME will share the feedback. Clear? Okay, one more thing. If you are not receiving the feedback, right, and you are expecting, you are asking for the feedback during the evaluation phase, then we will not provide. So it is your duty to ask for the feedback from your SME if you are not receiving within 8 days from the deadline. Clear? Okay, now we are starting the today's session. Okay, because I have already taken more than 40 minutes, right? So that's fine. Okay, so basically before starting on the before starting on the any project, first we should read the problem statement. Okay, so here some details are mentioned, like sometimes the details are given, but sometimes they are giving very small details, right? So you have to do the analysis to identify each and every parameter, right? So here they have mentioned that the data set contains the data of the customer. So basically this data is basically related to the customers. On the basis of the data, we have to predict the churn rate by the customer. So basically in this line they have mentioned that based on the based on the given data, we need to predict the churn rate, okay, by the customer. Okay, now what is churn rate? Churn rate is also known as the attrition rate, because they have clearly mentioned here the churn rate is also called as attrition rate, right? Attrition rate means when a particular, right, when a group of people are switching from one place to another place, that is also known as the attrition rate. But if you are asking in terms of industry, then it is a measure of the number of individual or items moving out of a collective group over a specific period of the time. Clear? Means they are moving out from one place to another place, right? Or you can say switching, like in our industry. You are working in any company, right? So companies are hiring, they are also firing the employees, right? There are also employees those who are switching, right? So basically, whenever there is a board meeting, the companies used to give the details to their investor, right, to their CEO, like means to give, they are giving the details to the upper management, where they are mentioning number of employees those who have switched, right, number of employees those fired, then how many employees they basically recruited, right? So such kind of details are basically shared by any company, right? Now, it is one of the primary factors that determine the steady level or steady state level of customers or a business will support, right? Then the term is used in many contexts, but it is most widely applied in business with respect to a contractual customer base, right? So basically, if you are working in any company, that doesn't matter, you are working as a full-time employee, you are working as a contractual based, right? So everything comes under the contractual base, because you can switch anytime, right? Right, you can switch anytime from one company to another company, and the company have to manage the report so that they can identify what exact problem are basically faced by the employees. For example, if their services are not good, if you are working in any company and the company is not giving the basic data, basic services, right, in that case, definitely you will look for a company where you are getting the more knowledge, where you are getting the good package, good profile, you are getting a chance to learn the new skills the along with the services, right? So if they want to improve, right, or if they want to make changes in certain field, like, then they need to collect such kind of data, right? Now, for example, here they have mentioned that, for example, in businesses with a subscriber based service model such as mobile telephone networks and pay TV operator. Okay, so basically they are saying these kind of business, the churn rate is basically most important in the business where a subscriber based services like as mobile phone network and pay TV operator, right? So basically you are recharging your Wi-Fi, right? You are taking subscription of Amazon Prime, right? Then you are taking a subscription of Disney, you are taking a subscription of Netflix, right? So basically these are the these are subscriber based, means you are paying the money for the subscriptions, right? Once the subscription is over, then again you have to pay the money. For example, I have taken a subscription of Netflix for 1 year, right? That is, for an example, that cost around 2000 per annum, right? But next year I'm searching for another subscriptions, and I'm finding out that okay, the Amazon is providing good content in a less price than the Netflix, or the Amazon Prime is giving more facilities, more services, then definitely I will switch from Netflix to Amazon Prime. I can also purchase the subscription of different companies, right? Now, the term is also used to refer a participant turnover in peer-to-peer network. Churn rate is an input in the customer lifetime value modeling and can be a part of simulator used to measure the return of marketing investing using the marketing mix modeling. Why? Because see, if I'm talking about any company, like in 2016, I think, right? There was one company that was launched, that is Geo, right? Geo company has launched the SIM, right? During that time, the main most of the customers were from Airtel and from the Vodafone Idea. There are 3 or 4 markets in India, right? And most of the customers were there. And at that time, the price of internet was high. That was basically around 400 or 500 rupees per GB. But when the Geo was launched, at that time they changed the game, right? They changed the game, and how they changed the game? Basically, they uh, during the initial phase they give everything without any paying, without paying a single rupee, right? So basically, at that time, they were giving more services. They were giving fast internet speed, right? They were giving unlimited internet services. They were giving unlimited calls, right? So the most of the customers have switched from Airtel, Vodafone, and from other operator to Jio. Okay, so why they are switching? Because as a customer, definitely I am looking for a profit. Even the company is also looking for the profit, but as a customer, definitely I will look for my personal profit. If I'm getting good services, right, in a cheap rate, then definitely I will switch to a new operator, right? That is the case in everywhere, right? So what the companies are doing, they are basically investing more to retain their existing customers instead of acquiring new customers. Why? Because the loyal customers are giving them a constant amount, constant profit, right? The new customers are switching. For example, if you are switching for if you are switching company and every 6 months, then definitely the new company, if you are going to if you are applying for a new company, they will look into it and they will find out, okay, this this particular candidate is switching every 6 months, right? Then they are avoiding such candidates. Why? Because maybe you, if you are working on any particular project that is important, your role is important, and you are running behind the money, or you are running behind a good technology, right? Then definitely when you will get the opportunity, you will switch again within the 6 months, right? So in that case, whenever anyone is investing, they are looking for a loyal person, right? Doesn't matter it's a company, doesn't matter you are working as an employee or you are working as an employer. Right? So that is the case there. So every time the companies are investing more to retain their existing customers instead of to acquire a new customers. Okay, so at that time the churn rate plays a very important role, so that they can identify what is the reason behind their existing customers are switching from their operator, from their company to another company. Clear? Okay, so from reading the problem statement, we find out that the data set contains some data, that is customer ID, gender, senior citizen, that is basically related to the customers. And then after that, we need to predict the churn rate by the customer. Okay, we need to predict the churn rate by the customer. And while reading the data, we find out that there is a column with the name of churn. Okay, so it means this is a supervised machine learning problem statement where the variables means features, independent features or independent variables or input variables are present as long along with the target variable, or you can say dependent variable. Clear? Okay. Then after that, first we will import necessary libraries. Library means I'm going to use pandas, I'm going to use numpy, I'm going to use seaborn, matplotlib, right? So I'm going to use these libraries, right? Then after that, if I need more libraries, then I can import them later. Then after that, I am importing one more library, that is basically import warnings, and warning dot filter warning ignore. It means I am importing this library to ignore the warnings. Okay, if you are getting any warning related to any particular library, any particular code, then you can ignore it. But if you're getting the error, then you cannot ignore it, right? You have to solve the errors, right? But you can ignore the warnings, right? now Now here I am reading the data by using PD. PD, that is basically alias of my pandas. PD.readCSV. I am using the readCSV method. Why? Because my data is in CSV format, right? So here I am passing the raw link of the GitHub. Okay, I am passing the raw link of my of the file that is basically uploaded on the GitHub. Okay, I will let you know at the end of the session how to find out the raw link of the file. Clear? And also I will share the link of the dataset so that you can practice after the session. Okay, so here https://raw.github, you can say github user content.com. Then after that, here the name of the file is telecom underscore customer underscore churn.csv. Okay, so basically this data is present in the CSV format and it is uploaded on the GitHub. So we are directly reading the data from the GitHub. Okay, then after that we are checking the data. So here you can see here the data is customer ID, gender, senior citizen, partner, dependent, tenure, phone services, right? So many data. And then after that here in between there are the three dots are there. Three dots means there are more number of columns between present between the online security and the device protection, right? And at the end of the the last column is basically churn rate, right? In the churn rate we can see some values, no, yes, no, yes, and then after that dot, right? Then after that again no, yes, no, yes. So here if you just see here, so basically you will see the size of the data. The size of the data is basically 7043 rows and 21 columns. So if I'm asking for the size of the data, then the size of the data is 7043 rows and 21 columns. Clear? Now here I'm writing the observation. What is my observation? This dataset contains the details of the customer in which both numerical and the categorical data are present. Numerical and categorical, why? Because here you can see the categorical data is present 0, 1, 2. Then after that here numerical data is present, right? Here churn is our target variable because it is given in our problem statement. Then after that which contains two categories. Here I have mentioned two categories. So it will be determined as classification problem. Please let me know whether this written statement is correct or not. Please let me know. I have mentioned that here churn is our target variable, that is correct. Then after that I have also mentioned that which contains two categories, so it will be a classification problem. So please let me know whether this written statement is correct or not. Mr. Harsat Pawar, if you have a family emergency, then definitely you can leave the session. Okay, I will share the recorded video of this session with your institute, and they will upload on their forum. You can check them. You can check from there, and you can practice. And then after that, if you need any kind of assistance, then you can raise a ticket to your SME. Clear? Okay, someone is saying yes, it is a classification problem because it has two categories. Seems to be correct. Someone is saying okay, correct, correct, correct. Okay, but if you okay, most of you are saying yes, the given the written problem statement is correct. But please let me know because here you can see I can see 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. Right? The total size of my statement, the total size of my data is basically 7043 rows, but I can see the data of only 10 rows. And in the 10 rows, you are just checking the no yes, no yes, no yes. And based on the 10 rows, you are deciding for the remaining 7033 rows. How I can decide whether only the no and yes will be present in the remaining columns, in the remaining rows? Let me know how you are able to decide whether it's a classification problem, how you are able to decide it has only two categories. Right? Because most of you are saying yeah, we need to interchange no with zero and yes. You cannot decide here because we are not aware about the number of data, number of unique values present in the target variable. We are just checking the data of 10 rows, that is basically first 5 rows and the last 5 rows. And based on that you are making observation for the remaining 7033 rows, right? Okay, we will use the describe function. You can use any method, but I'm asking about this statement because after writing any code, after using any library, you have to write your observation based on the output. So based on the output, I have mentioned that here, which contains two categories, so it will be termed as the classification problem. Okay, so the problem is that you cannot decide directly. First of all, you have to check everything. That is known as the data pre-processing and feature engineering, right? That's why we are using the EDA part. In the EDA, we are using non-graphical and graphical analysis. Someone is using describe method. So we are using different methods so that we can get more information, right? We can get insights from the data. Insight means the more information about the data. Clear? Okay, so when I mentioned here which contains two categories, so it will be terms and classification problem where we need to predict the several churn using the classification for model. So basically the statement written here is neither correct nor incorrect. Why? Because we are not aware about the remaining data. Okay, so that's why I have mentioned here, because whenever, okay, because whenever you are writing anything, make sure first check the output. If your written observation is not matching your output, then definitely we will deduct the marks. Also we will mention in the feedback. Okay, right? Okay, then after that I'm using the df.head. Okay, I'm using df.head, and again here in the head column is basically head is used to get the information about the first 5 rows and all columns, right? But by default it is 5, but here I'm mentioning the 15. Then it will fetch out the information of first 15 rows and all the columns. And here if you scroll down, here you can see the index value is starting from 0 and ends on 14, and here the size of the data is 15 rows and 21 columns, right? So here in the customer ID, I can see there is a data that is basically alphanumeric, that is basically giving the information about the unique identification of the customer. Then after that, the gender is there, like male, female, and so on. Senior citizen, there are two possible values, 0101, partner, dependent, 10-year, phone services, multiple lines, internet services, online security. Then after that, monthly charges and total charges and the churn rate. Clear? Now, in the same way, if you want to find out the information of the last 10 rows or last 30 rows, any number of rows, then you can use data frame.tail method, right? But if you want to see the information of columns that is basically present in between the first rows and the last rows, then in that case you can use different methods, right? There are so many methods in the Python which you can use to get the information, right? Then after that, here I'm starting the EDA part here, and we are checking the dimension of the data, and for that we are using the df.shape that we have already discussed. So here the 7043 rows and 21 columns, and I have clearly mentioned that this data set contains 7043 rows, 21 columns, out of which one is target variable and remaining 20 are our independent variables. Clear? Then after that, I'm using df.columns. Df.columns is basically giving the details of your columns, right? Basically, it is giving the name of the columns of your data frame. So here you can see the customer ID, gender, senior citizen, partner, dependent, 10-year, phone services. And at last, they have mentioned about the D type. D type is basically mentioning about the data type. So here the data type is object. So basically this data type is object, means this is a string data, right? But it is not representing about the data which is present inside the columns. For example, in the monthly charges column, some numerical values are there. For total charges column, some float values were there. For the gender column, string values were there, right? But here you can say the D type is object, because the D type or the data type is object because it is giving the information about these values, and here these values are basically considered as the string values. Okay, this data type is not representing the data type of the data which is present inside these columns. This data type is basically representing the data type of the values written here, that is customer ID, gender, senior citizen. So basically this the values written here are string values. That's why here the data type is object, right? If you want to convert to list, then you can use the to list method and you will get all the details inside the list. But here you are not giving inside the, you are not getting the values inside the list. Clear? Because basically it is giving the index details. Then after that, then after that I'm checking the types of the column, and for that I'm using df.d types. Okay, and here you can see for the customer ID our data type is object, for gender object, for senior citizen it is int64. Why? Because the values were something 0 1 something like that, right? And then for the partner, again here the object, for dependent object, for int. Okay, okay, clear? For dependent object for 10 year, then after that again in 64 phone services object object object, right? And for the monthly charges column again float, right? Then for total charges column it is object. Okay, in the total, for the total charges column the data type is object, for the churn again it is object. So but if you look on this data like first 15 rows are from, for first last 30 rows, then here you can see for the total charges column the values are basically in the float values: 3756, 3645.75, 2874.45, 49.95, 1020.75, right? So here you can see in the last 30 rows only the float values are there, right? Even no null values are there, right? And if you check for the first 15 rows, again you will see the only the float values are there. But again the same case is there, we are checking only the data for the 45 rows, right? We cannot decide for the remaining columns. Now can you please let me know what can be the possible reason for the total charges column, the data type of total charges column is object? What can be the possible reason here? Are those two categories are numerical and categorical. So basically numerical and the categorical are two different kind of data. Okay, whenever we are talking about the data, then the data is divided into two parts. First one is your continuous data, or you can say numerical data, and then after that second one is categorical data, or you can say discrete data, right? So after the in the discrete data again there are different branches are there, right? Numerical, for the numerical values as well, the in the numerical values discrete data is present, for the categorical values discrete data is there, right? Okay, someone is saying, I think NaN values are there. There might be some string entry in between. Okay, and there can be NaN in the charges column. Okay, missing data, maybe some data was missing, which is written as maybe no data. Okay, some different can be present other than the float and int. Okay, other there can be null values, some characters may be present in the total charges column which is to be cleaned and converted to float. Okay, so most of you are saying different, giving different reasons, right? And all the possible, all the reasons can be a possibility, right? So there can be, but those who are saying NaN values, first of all let me tell you whether none, NaN or np.nan values are there. Okay, then these values does not have any data type. If the nan values are present inside any column, then it is not changing the data type of the column. Please you need to understand that if in a column there are there are some numerical values are there, and if for some places the nan values are present, then they will not change the data type of the column. Okay, because the nan values does not have any data type. Clear? They are not representing the numerical value, they are not representing the float value, they are not representing the string values, so they will not change the data type of your column. Clear? So here we need to find out what is the reason behind the float value. Okay, why? Because okay, then after that we are representing the data type of our column, that is int64, right? Then float and object, right? Okay, so basically there are three data types are there here. Okay, there are three data types. First one is int64, that is basically there are two columns with the int64. Then float, there is one column. Then object data is present in our data set, right? Then after that, we are going to check the null values, because some of you are saying maybe that nan values are there. Nan values means null values. So for that, what we are using, df dot is null dot sum, and here you can see is null is basically used to find out the null values, and dot sum is basically taking the sum of the null values in a particular column. So here you can see the customer ID. For the customer ID, the values are 0. Please wait a minute, okay? So basically here you can see the df dot null is null dot sum is value is basically 0. So from this output we can see that okay, there are no null values are present in any column. Like in the customer ID, the null values are there 0, for the gender column 0, senior citizen 0, partner 0, right? So basically in all the columns there are no null values, right? Then after that we are taking the df dot is null dot sum. Basically the second sum is basically taking the sum of these values. Again the null values are 0. Now, to find out the more information about the data frame, we are using the df.info. Okay, someone is saying, sir, why you are using the df? Basically, df is a data frame. Okay, here you need to understand that. Okay, whenever you are reading the data, okay, by using the pd.read.csv, right? So the data is basically converted into the data frame. Okay, the data is converted into the data frame. So if anyone is saying why we are using the using the df, so basically I am writing the df to represent the as a data frame, but this is a variable name, right? And you can change any time. You can change, you can write anything in place of the data frame, okay, in place of the df. But whenever you are reading the data, it is reading the data, and then after that it is storing the data in the data frame. Okay, so if I'm saying what is this, so basically this is a data frame. Okay, that's why here I'm writing the df. Clear? Okay, then after that here I'm using the class dot when I'm getting the information. So here you can see for the class, first of all here it is mentioned that the pandas dot core dot frame dot data frame. So basically it is giving the detail, it is giving the data type of the data df variable. So here from this output we are clear that the df is basically representing the data frame here. Okay, then after that it is giving the range index value. There are basically total 7043 entries, which means number of rows starting from 0 to 7042. Means here the index values are starting from 0 to 7042, and the total number of rows are 7043, right? Then the data column, there are total 21 columns. First one is the column name, that is basically customer ID. In the customer ID, the non-null count means the number of non-null values are 7043. The data type is object. For gender, same, right? Now after collecting, here they have mentioned about the d types. Basically the float column, how many columns are there with the float data type? So basically the number of columns are 1. How many columns with the int64? There are basically 2. Then after that, how many columns are with the object data type? That are basically 18. So basically out of 21 columns, 18 columns are with the object data type, 2 with int64 and 1 with float 64. And the memory usage is basically 1.1 plus MB. Okay, and from the above graph, from the above output, we can find out, because for all the columns the total number of non-null values are 7043, 7043, 7043. It means there are no null values are present in this data set. Clear? Now then after that we can see there are no null values, we have clearly mentioned that. And to see by using the graph, we are using the heat map, and for that we are using cborn.heatmap, and inside that we are passing the df dot is null method. Now what is the use of heat map? Heat map is basically giving the details, right? It is a color representation, a graph with the color representation. So here you can see I'm using the df dot is null dot sum. So On the x-axis, they are giving the name of the column name like customer ID, gender, senior citizen, partner, dependent, 10-year, phone services, and so on. On the y-axis, they are giving some range like 0 to 71, and the maximum value is 6,775. Here there is one more bar, and this bar is basically representing some color code. So here you can see the range value is basically negative 0.10 to 0.100, right? So here negative 0.10 is representing with one color code, negative 0.075 is representing with this color code, and so on, right? For 000 is basically the color code is basically exactly the same color code that is present in our heat map. Why? Because we are using the heat map to find out the null values, and here you can see for the customer ID, genders, partner, for all the columns there are no null values, means there are zero null values. That's why the color code for whole graph is same, because here you can see the color code for 0 values is this one. Clear? Okay. Now then again, then after that we are going to give more information. We are going to collect more information about the total charges column, because we have identified that in the total charges column the float values are there, but the data type when we are checking, it is object, right? It is object, and we are not clear about that reason, right? So we need to find out. So whenever you are collecting the data, and data should be in appropriate data type. If it is not, then you have to first analyze the data. You have to find out the more information about it, and you have to convert into the appropriate data type. Clear? Now, here we are using the unique function on the total charges column. Why the unique function? Because the unique function, it gives the list of the unique values, right? So here you can see the array 29.85, 1889.5, 108.15, 346.45, 306.5, 6844.5, and again it is giving the details of the d type is equal to object, because the data type is object. Okay, before moving ahead, can you please let me know what is the data type of a variable? Please let me know what is the data type of this variable. Okay, someone is saying float, someone is saying object, someone is saying a string, someone is saying just because it has decimal values, so it will be a this float values. Okay, it is a string because some reason. Okay, people, your answer is basically correct. Object, string, object, object, object. No. So basically, okay, yes, yes, yes. Okay, so basically, if I want to check the data type of the a variable, and here I'm writing, then you will see the output as a string. Why it is a string? Okay, someone is saying object. Why it is not object? Please let me know. Those who are saying object, their answer is correct, but why it is not object? Okay. Can you repeat the question again? I am asking why the data type when I'm checking the type is equal to be, why it is a string, why not object? Like some of you are saying the data type should be object. Some of you are saying the data type should be string, right? So those who are saying a string, their answers are correct. Those who are saying object, why it is not in object? Please let me know. Okay, it is an object, it's object, but its type is a string, okay, which represent float variable. The text value always written in quotes. See, first of all, let me clear you that why is it a string? Someone is saying, okay, in okay, first of all, you need to understand that whenever you are writing anything inside the double quotes or single quotes, it is considered as a string. Doesn't matter whether you are writing a number, whether you are writing a float value, right? Everything will be considered as a string. That's why here the data type is a string. Now the question is why it is not object, because you need to understand that in the data frame, whenever you are talking about the data frame, then the string is not represented as a string. In the data frame, string is represented as a object. Okay, and just because this value is not a part of the data frame, that's why here the object, here the data type is a string. But if the same value was a part of data frame, in that case it will be object data type. Okay, so if I'm saying here the object data type is there for the, okay, now not because of the PD, because of the data frame. Okay, PD is basically a pandas, it is representing the library, pandas library, right? So basically here if I'm saying the object values are there, so here it means the values are in a string format, and from the output you can see inside the array the values, all the values like 29.85, 1889.5 and other remaining values are present inside the single quotes, right? Here you can see the values are present inside the single quotes, right? So this is the first reason now, right? This is the first reason of object data type for the total charges column, right? Then after that we are checking the n unique values. So basically in the total charges column the number of unique values are 6531. How many unique values are there? The total number of unique values are 6531. So basically if the number of, and the total size of the data set is 7043, so it means out of 7043 values 6531 values are unique. So in that case, okay, it should not be considered as a string values. If it is in a string format, then we have to convert it, right? Because if the values are present inside the single quotes, then we have to typecast it. Please let me know what is the meaning of typecasting. Adding, converting data type, changing a variable data type, okay, to change the data type, conversion, converting a lower data type to higher. Basically there is no lower data type and there is no higher data type. Okay, so basically whenever we are converting the data type of any particular data, okay, from one data type to another data type, then it is known as the typecasting. Clear? It is not limited to variable, because in the variable we are storing the data. Okay, so we are not changing the variable of the we are not changing the data type of the variable, we are changing the data type of the data that is present inside, that is stored inside that variable. Clear? Okay, then after that, okay, so here you can see the total number of unique values are 6531 and the values are must be float. right? So we need to typecast it. But before that, we have to check more reasons. What can be the reasons for the object data type? Because we have already got one reason, that is basically all the values are present inside the single quotes, right? Then after that, what we are doing, we are checking the value count function for each column. Value count function is basically giving the details of the total number of unique values, as well as it is giving the information about the frequency of each unique variable, each unique value inside a particular column. So for example, here I'm using the for loop, and I is our iterator that will iterate over the df dot columns, means for the index of all the columns. And here I'm using df dot I dot value count function, means for every column, for during each iteration, for every column I'm using the value count function. So here you can see during the first iteration, it basically it checked the customer ID column, and here you can see the values are there and the frequency. So here you can see for all the columns, the frequency is, for all the values the frequency is same. It means right. And then after that, here the length is given. The length is basically 7043. So the length is basically representing the number of unique values. So in this column, the total number of unique values are 7043. It means all the values are the occurrence of each value is 1. Okay. Then after that, d type is int64. Here the d type is basically representing the data type of these values, means the frequency values, right? Then after that, here the second column is male, and the sorry, second column is gender, and there are two values, that is first one is male and the second one is female. The value count function of the male is basically 3555, and for the female is 3488, right? And again the d type is basically int 64. Why? Because it is representing the data type of these values, the frequency value, right? Not the data that is present inside the column. Okay. Then after that, for senior citizen, there are two possible values, 0 and 1. The count is basically 5901, and so on. For the partner, again there are two unique values and their count values there. For dependent, there are two unique values and their count is there. For 10-year, the count values are different. For the one, it basically the number of occurrences are basically 613. For 72 is 362, and the total number of unique values in the 10-year column is 73. Clear? Then after that, phone services, there are two possible values. For multiple lines, there are three possible values. For internet services, there are three possible values, and so on, right? Then after that, for the streaming movies, contract, paperless billing, payment method, right? Then after that, for monthly charges column, again the total number of unique values are 1585 out of 7043. Then after that, for the total charges column, the total number of unique values are 6531. But if you check here, the frequency of a blank value, of a white space value, is 11. Means the white space has repeated what maximum number of times, that is 11. The 20.2 again repeated same number of times, that is 11. Then 19.75 9 times, 20.805 8 times. It means there can be one more possible reason, and the other possible reason is there are 11 places where the white spaces are present, right? Here you can see nothing is there. It means white spaces are there. Okay. Now then after that, churn column. In the churn column, now we are able to identify that there are only two possible values, that is no and yes, and their count is 5174 and 1869, right? So here we are writing there are the value, these are the value count of all columns, and we can see the blank value in the total charges column. So again we are checking the unique values. The unique values are same, right? Okay, someone is saying, sir, I have already mentioned that there are some null values. Again, let me tell you, there is a difference between the null values and the white spaces, right? If you are writing anything in, I think whenever you are creating any string, right? Then the, okay, for example, just wait, let me take one example. A is equal to, I'm writing data, then space, again one more space, and then after that I'm writing science, right? And if I'm taking the length of a, okay, length of a, then you will see the output 13. But if you count the data and science, the total length is 11. Now why it is 13? Because there are two white spaces are there. right? So in the Python, okay, void spaces has a different meaning, and whenever it is inserted inside the string, then it has a space. It is considered as a value, okay, and the blank value is a different thing. Okay, so the blank value is a different part and the void spaces are a different part, right? Sorry, blank value, I'm saying the null values are a different part, right? It's a different thing, and the void spaces or the blank value is a different thing. So here I am saying here the void spaces or the blank values are there, but I have never mentioned like there are null values are there. Okay, so when you are mentioning about the null values are present, that is a different case here. Okay, I am not saying there are null values, I am saying there is a blank value or void spaces. Clear? Okay, now then after that we can notice that a total charges column has continuous data, but it is reflecting as object data type, and 11 records of this column has blank or white space data. Let's handle this column. Now we are using the df.log so that we can find out that the locations where the white spaces are present. Okay, so here we are using df.log. We are applying on the total charges column, and in the is equal to means we are comparing what white spaces. So here you can see for the index value 488, right? 488, the in the total charges column nothing is present, right, for all these locations. And what are the total count? The total count is 11 rows. What are the index values? The index value is 488, 753, 936, 1082, 1340, 3331, 3821, right? So basically on these locations, the in the total charges column white spaces are present. Clear? Or the blank values are present, but I'm not saying the nan values are present. Please remember that. Okay, now by locating the total charges column, we find out this column has a space or blank value as values, but it is showing zero missing value in the column. Clear? Zero missing value. Why? Because white spaces has a different meaning. Now let's fill this column by some values. Now what we are doing here, we are applying df.total charges column. Okay, here we are applying df.total we are applying the replace method on df.total charges column, and the old value, that is basically white space, I want to replace the white spaces with the np.nan. Okay, it means we are replacing the white spaces with the nan values, and whatever the changes we are making, we are storing in the same column. Then after that again we are using the value count function, and here you can see for the 20.2 the 11 white space, the sorry the maximum the 20.2 is the value that repeated maximum number of time, that is 11, right? And now here you can see the length is 6530. Okay, the length of means the number of unique values are 6530, but if you check the previous one, here the number of unique values were 6531. It means the number of unique values are decreased. Okay, earlier it was 6531, now it is 6530. Why? Because we have replaced the void spaces with the null values, right? And the null values is not counted as a unique value. That's why here the total the length means the total number of unique values is decreased. Now again we will check the df dot is null dot sum, and again we are checking the sum values and the sum of the null values, and here you can see in the total charges column now 11 null values are there. Earlier it was 0. Why? Because the white spaces were present, but now we have replaced the white spaces with the non values, that is basically null values. That's why the total count of null value in the total charges column is 11 instead of 0. Clear? Okay, since there are just 11 blank values, can't we go for deleting these rows? Can we delete because it's a small quantity? Okay, can you please first let me know what is the rule to create a data frame? Please let me know what is the rule to create a data frame. Okay. Can we replace null values by mean? We will see. Okay. But my question is, okay, all columns should same. all columns should not be same. Again, I'm saying you have mentioned that the all columns should be same. This is incorrect. Okay, all columns should same. Okay, it represent table like structure, I know, right? But here I am talking about what is the rule to create a data frame. The most important rule is the size of all the columns must be same, or you can say the number of rows in all columns must be equal. Same, not okay, must be equal. So if you are saying, yeah, column size must be same, the length should be same, right? Or the number of rows must be equal in all columns, that's correct. But if you are saying why we are not directly deleting these 11 columns, if you are deleting these white spaces from a particular column, then the size of all the columns will not be equal, right? But as per the rule, it must be equal, right? Second thing is, but if instead of deleting that particular values from a particular column, you are removing the data from whole data frame, means you are removing those 11 rows from whole data frame. In that case, it will lead to data loss, because why 11 white spaces are present in one column but not in remaining 20 columns. Okay, so for the remaining 20 columns, if you are removing, so it means you are removing around 200 plus entries. Entries means data for a particular. I'm counting for each and every column, right? Again, it is a data loss. So before removing the values, null values, or before removing the rows, you must have a valid reason. Okay, and to get the valid reason, first you need to do the analysis, right? And we always try to not remove the relevant data. If there is a relevant data, you can remove it. Okay, but for a small amount of irrelevant data, you cannot remove the whole data. When you have the choice, when you have the ways to replace those irrelevant data with some other data, right? Okay, then after that, total number of unique values are 11. And again, if we are checking the df.info, so here you can see in the total charges column, the total number of non-null values are 7032 instead of 7043, right? Now we are going to change the data type. Okay, why we are changing the data type of our column? Because we have already changed the white spaces, right? We have replaced the white spaces with the non values, and we have already checked that all the values are present inside the single quotes, so they are basically string values. We have also checked that for all the columns, right, all the unique values were basically related to, were basically holding the decimal values inside the single quotes, right? So we are going to typecast the value from string to float. And for that, what we are doing, we are using df on the df total charges column, we are using as type method. And inside that, I'm using the float because we are changing the data type of the total charges column from string to float. And whatever the changes we are making, we are storing in the same column. And after that, we are checking the data type. Here you can see, if you are checking the data type, it is the float 64. Now we can see the total charges column has some spaces, right? Values which is replaced by nan values, and now we have converted into the float data. Now we will handle the nan values. Again, if we check the in df.info, so here you can see there are 11 null values, but the data type has been changed from float from object to float 64. Clear? Okay, done. Now we have converted the data type, right? We have done everything. We have checked the null values. There are 11 null values, right? So now we are going to replace the null values. Okay, we are going to replace the null values. And to replace the null values, first of all, you need to see what kind of data is present inside a particular column, right? If the categorical data is there, then we will use the mode. You can use the import, you can use the imputer. Okay, you can directly replace the values by using the appropriate method. Now the question is why we are using the mean, median, or mode? Because if I'm taking any random value, then it can create the biasness. Okay, if I'm saying biasness means For example, if I'm taking very low value, then again it will be considered as an outlier. If we are taking very large value, it will impact the overall value, right? So what we are doing, we are using some method for the categorical data. We are using the mode to fill the null values. If the data is basically your continuous data or the numerical data, in that case we are taking either mean, okay, or the median. If there is more outliers, then we are taking median, right? Otherwise we are taking the mean, okay, and you can choose any one of them, either mean or the median, okay, to fill the null values in a continuous column. So here you can see the float data type, just because this is a float data type and the number of unique values is 6531 out of 7043. So this is a continuous column. So here either we can use the median or the mean to fill the null values in this column. So here we are checking the mean of the column, that is basically np dot mean in the df total charges column, and the output is 2283, right? Now here we are checking again the information, okay, let it be, okay. Now here we have checked the mean value, that is basically 2283.3004008, something like that, okay. Now we are filling the null values with the mean, and for that what we are using, we are using df total charges column, and we are using fill na method to fill the fill the values, the null values, okay. Fill n is basically representing the filling the null values with the mean of the total charges column, okay. After that, here you can see, after replacing the null values, we are restoring the all the changes in the same column. And after that, if I'm checking the df dot is null dot sum, and here you can see that in the total charges column the null values has been removed. Clear? Vipul Anand, it is not importers, okay, it is imputers. Clear? Can't we directly fill the wide value directly by the mean? Basically, if the values were string values, so for the string values, how you can use the mean? First of all, you have to typecast it, right? Okay. Now, then after that, again, we are checking the heat map. And after, when we are checking the heat map, again, you can see for the 00, there's a color code and there are no null values. That's why the same color code is there, right? Now we are checking the df dot ilog method, and in the ilog method we are taking the 488 row, because in the index value 488 there was wide spaces were present, and we are considering all the columns. So here you can see for the customer id there are some value, gender, female, and so on, but for the total charges column the value is 2283. But what about the earlier? If you check here, when we are checking from the 488 column ilog function we were using, and we are checking all the values, so in the 488 column when we are checking the total charges column, it was nan, because we have replaced the white spaces with the nan values in the index value 488. but after replacing after replacing the nan values, when we are checking for again for the 488 column, and here you can see for the total charges column the value, the nan value has been replaced with the 2283. So what we can do, what we can say, it means we have replaced the null values, right? We have replaced the null values by using the mean of the same data. Now here we have mentioned that now we can see there are no missing values in any of the column. Clear? Okay. Now we are separating the numerical columns and the categorical columns. Okay, please let me know what is the difference between the numerical column and the continuous columns. What is the difference between these two columns? Please let me know as soon as possible, because we are already running late, right? Please let me know what is the difference between the numerical column and the continuous column. What is the difference between these two types of data? Saying numerical columns contain values, numerical column can measure and categorical not. I'm not asking about the categorical data, I'm asking about the continuous data. Right? Categorical column contains categories and not so are okay. Categorials, okay, categories, numerical values and numerical data, numerical categories, but continuous has a data spread over a region. Okay, numerical just random numbers and continuous data is like temperature values. What is the meaning of temperature values here? Okay. Most of us saying numerical values have int and continuous has float data. Okay. Continuous variable can use infinite number of values within a given range. That's correct. Okay. Continuous means any range value. Numerical means specific range. That is also correct, right? But if we are talking about in numerical, like in general, then the numerical values where the numbers are present, and the numbers, right? The numbers can be integer as well as the float. Okay, I have not asked about the difference between integer and float. I have asked the difference between the continuous data and the numerical data. Okay, so in the numerical data, the numeric values means integer as well as the float values can be there. Okay, those who are saying the numerical values have int and the continuous will have float, that is not the correct thing. Okay, second thing is continuous variables can use infinite number of values within a given range. That's correct, right? And whenever we are giving this statement, that time it implies that there should be number of decimal values can be possible, because if I'm saying how many values are present between 1 and 3, so there are number of values are there, because after the decimal point we can write any number of values. Okay, there is no limit. Clear? Someone is saying numerical data name suggests represent numbers. That's correct. Okay. So here, so you need to understand that how you are going to find out the difference between the numerical and the continuous data. Okay. Because at the some point of the columns, there was the data type was int 64, but for some columns, the data type was float 64. Right. Now here we are separating the column based on what we are separating the column into the numerical and the categorical column. Categorical column where the categories, the data is present in some kind of categories, or it is present in string data. Okay, now what we are doing here, we are creating an empty list that is named as the categorical column. Then after that we are using a for loop that will iterate over the df.dtypes.index. Means it is checking, first it is checking the d type, a data type of the data frame. Then after that is iterating over the index of the values, and if the data type of a particular column is object, then it will be stored. Okay, then it will be stored in a categorical column. Please wait a minute. Okay, so voice is not audible because I was on mute. Okay, so basically here we are here we are storing, if the sorry, if the data type of the column is object, then we are storing in the categorical column list, right? Now here we are checking again, we are using a one more loop. Okay, okay, and where we are saying if the data type is not object, means instead of the object, if there is any another data type, then we are storing in the numerical column list, right? Then after that we are printing and we are finding out in the categorical column customer ID, gender, partner, dependent, phone service, multiple lines, internet services, online security, and so on. For the numerical column, senior citizen, 10-year, monthly charges, and the total charges column. But we have checked that in the senior citizen column there were only two possible values, that was 0 and 1, right? For the tenure, it was around 73. For the monthly charges column, it was around 1600 or 1700 unique values. And for the total charges, it was around 6500, right? Now, okay. Now we are checking in the unique values. So here you can see for the monthly charges column, it is 1585. For tenure, it is 73. For senior citizen, it is 2. And for the total charges, it is 6531, right? So we have divided the data into two different parts. First one is categorical data and second one is numerical columns. Now, then after that, we are dropping the customer ID column. Okay, and here axis is equal to 1 because we are performing the operation column wise, and in place is equal to true because we are making changes in my original data frame. Okay, so why we are removing the customer ID? Because the customer ID is basically the information about the unique value customer ID of the customers, and it is not what contributing more towards the information, right? And whenever any column has all the values are same values, or it has all values are different values, then we drop that column, right? Then after that, df dot head, we are using the head values, and again we are checking the values, right? Then after that, we are checking the unique values, count values. Why? Because we have already confirmed that there are two unique values. Now here, if I am writing, okay, here if I am writing, there are only two categories present in our target column, that is yes and no, then that's correct because we have already checked the value count function. We have checked the other things, right? Then after that, okay, then after that, here you can see just because here there are two values, so this is a classification problem. Okay, now tell me what kind of classification problem is this project, right? There are classification problems, right? Again, the classification problem statements are divided into number of categories. So what kind of problem statement is this project? Okay, okay, so two of you are saying, okay, someone is saying Chan, I'm not asking about the target variable, okay, because here I'm asking about the uh, type of problem statement. Okay, so yeah, binary, though most of you are saying binary means when there are two possible outcomes in your target variable. So here there are basically two possible outcomes, either yes or no. That's why this is a binary classification problem, and the value count is basically no is 5174 and the yes is basically 1864, where the no stand for the customer who have not churned, means those who have not left the group, left the operator. And second one is yes, those who have already got churned from the company, or those who have already switched. Clear? Now we are using the describe method to get the description of the data. Description is basically, it is giving the summary of the data by considering few data variables, few points, that is basically count is basically representing the number of number of rows, okay, that has not null values, okay, not null values. So here the count is basically representing the not null number of rows in a particular column. So describe method is basically giving the details about the continuous column. Okay, so here there are only four numerical columns are there: senior citizen, tenure, monthly charges, and the total charges column. That's why it is giving the information about only these four columns. But if you are getting the information about the categorical column, then that's fine, right? But here you can see the count is basically 7043, 7043, 7043, and 7043. So what we can see, we can say that okay, there are no null values in senior citizen, 10-year, monthly charges, and the total charges column. Then the mean is basically taking is here reflecting the average value of the column, and here you can see the average of the column is 0.16, right? 162 32.37. For monthly charges it is 64, and for the total charges column it is 2283. The standard deviation here, the value is basically 0.36, 24.55, 30.09, and 2265. Similarly, the minimum value, that is basically the lowest value, 0. For the tenors it is again 0. For monthly charges it is 18.25, and for the total charges it is 18.80. 25 percentile, it is basically means first quartile of the data, that is basically 0, 9, 35.5, 400, 2.25. 50 percentile is also known as second quartile, or the median of the data. Okay, or the median of the data, and the median of the senior citizen is 0. The tenure is 29. For monthly charges is 70, and for total charges it is 1400. Now 75 percentile, or the third quartile of the data, is basically 0, 55, 89, and 3786. And the last one is maximum value, that is basically the largest value present. Here it is 1. Here you can see the minimum value was 0, maximum value is 1, because in the senior citizen there was only two possible values, 0 or 1. For the 10-year, the maximum value, the largest value is basically 72. For the monthly charges, it is 118.75. But for the total charges column, the values is basically 8,684. Clear? Okay. Now we are writing the description here. We are writing our observation. What is the observation? This gives the statistical information of the numerical column. The summary of the data set looks perfect since there is no negative or invalid values present. From the above description, we can observe the following things. First one is the count of all the columns are same, which means there is no missing value in the data set, right? Second one is skewness. Okay, please let me know how we can find out the skewness of the data based on this description. Please let me know. Okay, by checking the quantile, by plotting graph. Okay, 50% to 70%, 5%, how much deviation is there? Okay, so basically, whenever we are talking about the skewness, then we are not considering the quantiles, we are considering the difference between the mean and the median. Okay, because I hope you know that whenever we are looking for the skewness, means whenever we are checking for the bell-shaped curve, at that time there are three things are measured, that is basically mean, median, and mode. If the values of mean, median, and mode is equal, then it means there is a symmetrical data. Symmetrical data means the data is basically in bell-shaped curve. There is no skewness. Skewness means when the data is shifted towards one point, either positive skewness, negative skewness, or it is also known as right skewness or left skewness, right? Now, so if the mean and median is not equal, then there are different kind of skewness are there, and here we have clearly mentioned that if the mean value is greater than the median, okay, if the mean is greater than the median, then it means there is a right skewness. But if the mean is less than the median, then it means there is a left skewness. That's why here you can see, here we have mentioned that the mean value is greater than the median in tenure and the total charge column. So if you check in the tenure column, the mean value is 32, the median is 29. So basically the mean is greater than median. That's why it is in this column the right skewness is present. Okay, for the monthly charges column, the mean is 64 and the median is 70. Basically the mean is less than the median. Okay, it means there is a left skewness. If total charges column we are talking about here 2283, but median is again 1400. Here the mean is greater than the median, then again here right skewness is there. So that's why here we have mentioned that the mean value is greater than the median in tenure and total charge column, which means the data is skipped to the right in these columns. But the data in the column monthly charges have mean values less than the median, which means the data is skipped to left, right? But here also you can see, okay, you can also see in the third quartile and the maximum value there is a huge difference between you can see there is not huge difference between the this values. But if I am looking for the total just column, there is a huge difference between the third quartile and the maximum value. Again there is a difference, again there is a difference, but it means there are possibilities that the outliers are present in these three columns. Okay, now by summarizing, we can also observe there is a huge difference between the 75 percentile and the max value. Hence, there are possibilities that the outliers are present in the data. We can also notice the standard deviation minimum, standard deviation value, minimum value, 25 percentile, 50 percentile, and 75 percentile from the described method. Clear? Clear? Okay, when the difference between the mean and standard deviation is low as compared to the mean, okay, then there is a residual in the data. Yeah, basically, see, here this is a project there's a project discussion session, right? I cannot teach you everything which is already covered by your institute in 6 months. It is very difficult for me to cover everything in the session of 3 hour or 4 hour, right? So I'm just giving a basic idea. I'm giving a dummy session, demo session, okay, where you can know how, which method you can use, what kind of observation you can write, how you should write the observation, right? Here we can give, where here we can get more details, like you're saying residual, right? We can get about the skewness, we can get about the multicollinearity, right? Here we can check about the outliers. There are so many possible like outputs can be there. It based on your knowledge, right? Based on your knowledge you are going to observe different things. That's why I have clearly mentioned that the observation can be different from person to person. It is not mandatory that what is your observation must be same as mine. Okay, our observations can be different, and based on the observations we are making the decisions. That's why the machine learning is a hit and trial method. It's all about the hit and trial methods. Clear? Okay, because there is no standard steps in machine learning. Clear? So Bipul Anand, whatever you are mentioning about the residual, that is correct. Clear? Okay. Now we are moving ahead for the data visualization because we have already covered the non-graphical analysis. Now we are moving for graphical analysis. Now in the graphical analysis, we are starting with the univariate analysis, and univariate analysis means when we are doing the analysis by considering a single column, means we are performing the analysis on a single column, then it is known as the univariate analysis, right? So here for the churn column, just because it's a categorical column, so we are using the sns.count plot, and x is equal to churn, data is equal to df. We are taking the source of the data. Then after that we are printing the value count function, because by looking on the graph we can find out the approximate value count of each unique value in the column. For example, in the no, right, here the graph is basically around 5,000, so we can say that okay, the values, the number of no values are more than 5,000, but we cannot give any exact count, right? For the yes, it is around 2,000, right? So to get the exact idea, we are using the value count function. So here we can observe that there are two possible values. First one is no, second one is yes, where the no is representing the non-churn data, whereas the yes is representing the churn customers, right? Also here we can see there is a huge difference between the two unique values, so there may be, there is a possibility of class imbalance because this is our target variable. And when the difference between the unique values of, or we can say when the difference between the ratio or the count of the unique values is high, then there is a chance of class imbalance in a classification problem. Okay, now here we have mentioned that we can observe that there are the count of no churn are high compared to the count of yes churn, that is more number of customers who have not churn. Okay, this leads to the class imbalance issue in the data, and we will rectify it using the oversampling method in later part. Clear? Then after that, here's in the same way we are using the count plot for the gender column, and in the gender column here you can see the gender column is giving the idea about the male and the female, right? And by checking on the by checking the graph, we can say that okay, there are two possible values, female and the male. Okay, the count of the male is basically quite high, like little high as compared to the customers those who are female. And to know the exact count, we are using the count plot method. Clear? Then after that, we are checking for the senior citizen, and for the senior citizen, 0 is basically representing those who are not senior citizen, and 1 is representing those who are senior citizen. If you check the value count function, okay, and you can see the graph, there is a huge difference between the unique values of the senior citizen. But just because this is not our target variable, so we cannot consider this variable as a class imbalance problem. Okay, now here we have also mentioned that the count of 0 is compared to 1, okay, high compared to 1, which means the number of non-senior citizen are quite high compared to the senior citizen data in the data set. Clear? Now then after that, here again we are checking for the partner. Similarly, because the partner value, there is a means whether the customers are partner or not partner, right? And you can see there is a very less difference between both of them. Then in the same way, we are checking for the dependent. Dependent means we who are dependent on others, like there can be, they can be your parents, they can be your grandparents, or they can be your children, right? So here you can see that value, the number of customers those who are not dependent, their count is quite high as compared to the customers those who are dependent. Clear? Then after that, phone services. So basically the phone services are the customers those who are using phone services. Phone services can be anything, like for every company they are giving different kind of services to their customers, right? So the customers those who are not using the phone services, their count is quite less as compared to the users those who are using phone services. Okay, phone services means calling services, testing services, application, gaming, right, video calls, so many these kind of services are phone services, right? I hope you are using the same mobile, right? So please do not ask such a question, what kind of phone services, right? If you are using the technology, then you are well aware what kind of services are provided by the companies, right? Okay, now then multiple lines. So basically there are multiple lines. Okay, now there are multiple lines options in phone services. So there are three possible values. First one is no, those who are not using the phone services. So just because they are not using the phone services, then definitely they will not be able to use the multiple lines. Second one is no multiple lines, means they are using the phone services but they are not using the multiple lines, their count is basically high as compared to no phone services. And the customers those who are using the phone services as well as the multiple lines. Clear? Okay, so basically here we have mentioned that the customers having phone services from single line have high count, okay, because they are not using the multiple lines compared to the customers who are using phone services from multiple lines, right? Also the customer who do not have phone services have covered very less data compared to others, right? Then after that, online security. Whenever you are working on the digital platform, there is an online security term. Okay, so if you are not using the internet services, then definitely you do not have any threat. Okay, related to online security. But now the methods has been changed, right? They are giving different kind of links. But if you are not using internet services, then definitely you will not visit that particular. You will not be able to visit any particular website, right? So those who are not using internet services, they have very less chance of online security threat, right? Then there are customers those who are using online security, okay, those who are using internet services as well as online security. Okay, then after that, there are customers those who are using internet services but they are not using the online security. Okay, now in the same way, online backup means by using the internet services, you are taking the backing up of your data on the cloud platforms, right? Like you are using Google Drive, right? Or you are using Google Photos. There are so many Google Drives, sorry, cloud platforms are there that we are using to store our data. So here in the same way, df.online backup, in the online backup, again, if you are not using the internet services, then definitely you cannot use the online backup facility provided by your company. Then after that, no online backup means they are using the internet services, but they are not taking the backup of their data on the cloud platforms. And the third one is those who are using the internet services, and also they are taking the backing, they are taking the backup of their data, right? Then after that, device protection, there are three possible values: no, yes, no internet services. Again, the same case is there, right? Then after that, tech support, again the tech support provided by the company. Again, there are three possible values: no, yes, and no internet services. If you're not using no internet services, then currently it is quite possible to use the internet services, right? Then after that, yes and no. Then after that, they are also providing the streaming TVs. Here, if you're not using the internet services, then definitely you cannot watch the streaming TVs, right? You cannot stream the TV channels. Then after that, again, the count between not using the streaming TVs and using the streaming TVs is very less, right? Then after that, streaming movies, again, if you do not have an internet active internet connection, you cannot use the, you cannot stream the movies, right? In the same way, again, the count is very less, right? Now, paperless billing. Okay. Earlier we were using the paper billing, right? But now you in India we have the UPI, and number of customers, right? Those who are using the UPI for the billing are quite high. And in also foreign, they are using different kind of techniques. Like they are using different kind of uh, websites, technologies. Like they are using credit card, debit card, right, to pay their bills now. So there is no need of the paperless billing. Even most of the companies, they are giving the, they are sharing the bills on your registered email address, because they are avoiding the paperless billing. Sorry, they are avoiding the paper billing, right? So that's why they are switching to paperless billing. So here, those who are not using the paperless billing, okay, their count is quite less as compared to those who are using the paperless billing. Okay. Then after that, payment method. So here there are different payment method: electronic check, mailed check, bank transfer, credit card, right? And also there are different like here automatic means auto debit. Okay. If you are purchasing any term insurance, you are taking any subscription, so there are different options of the automatic debit. Okay, auto debit. So here you can see the account is basically almost same for all the methods except the electronic check. Then after that, we are checking the dist plot. Okay, why we are using the dist plot? Because we want to check the distribution of the plot, and whenever we are checking the distribution of the data, we are checking the distribution of a data in a particular column. So this also comes under the univariate analysis. Okay, so what we are doing here, we are using plt dot figure, and the fig size is basically representing the dimension of the figure, that is basically 10 by 6 in inches. Then face color is white. Then after that, we are creating a variable. Okay, we are initiating a variable with the value 1, and we are using the for loop that will iterate over the numerical columns, because whenever we are checking the distribution of the data, we check the distribution of the data in continuous column, because there is a concept of mean median. But in the categorical data, in the string data, we cannot take the mean or the median. Okay, now here we are using the for loop that will iterate over the numerical columns, and here we are giving one condition: if the plot number, this plot number is less than or equal to 4, then in that case we are using the plt dot subplot. Subplot is basically used to plot different plots, right, number of plots in a single picture, right? So here we have decided, here we have created the fixed size. Inside that, we want to plot different plots, right? So here we are giving the two dimensions, like the number of rows, number of columns, and the plot number, that is basically here the index value. Then after that, sns dot dist plot, and here we are inside the dist plot, we are taking the column. For first iteration, the first column will be fetched. For second column will be fetched, right? And color is equal to m. Then after that, we are giving the label name. The label name is basically for the x label, we are taking the column name. And then after that, font size is 12. The y-tix rotation is 0, font size is 10, and after that we are increasing the plot number by 1, because if we are not incrementing, then your loop will run indefinitely, because if the plot number is not increasing, every time this condition will be satisfied. Okay, if the condition is satisfied, again it will enter the loop, again it will enter the loop, and your code will run indefinitely, right? Then after that, plt dot type layout to print the output. So here for the density, for the senior citizen column, here you can see the density is basically to find out the how much data is present. Okay, so basically whenever you are checking the dist plot, the density will be there. On the x-axis you can see the senior citizen column. Here the range is basically negative 0.2 1.2. Okay, here you can see the maximum values are present at the 0.0, and then after that 1.0. Okay, so by looking on this graph, if you are checking, then we can say that okay, this is a left skewness case, right? Then after that, in the 10-year column, the range is basically between I can say from negative 20 to positive 80 or 100, right? And here you can see for the 10-year column, the data is basically skipped. Okay, but not that much skipped, because this is also not a bell-shaped curve. If this was a bell-shaped curve, then it should be in this phase, right? But here you can see it is in this curve, right? Then after that, monthly charges column. In the monthly charges column, again the range is between 0 to 140, and here you can see again the data is skipped, but not that much. Okay, but not that much. In the same way, for the total charges column, the range is basically from negative 2000 to 10,000, and here you can see most of the that data is gathered between 0 to 2000, right? And then after that you can see the slope. So here we can say that okay, the data is basically skipped. Okay, so that's why here we have mentioned that from the above distribution plot we can notice that the data almost looks normal in all the columns except the senior citizen. Okay, and the data in the column total charges is skipped to the right. Other two column 10-year monthly charges has very low possibility of the skewness, right? Skewness means there is some acceptable range of the skewness. Clear? Okay. Then after that, we are starting with the bivariate analysis. And for the bivariate analysis means when we are doing the analysis by considering two different columns. Okay. Whenever we are considering the analysis by considering two different columns, then bivariate analysis comes into the picture. Clear? Okay. So what we are doing here we are using plt.title, and we are giving a title that is basically comparison between the tenure and the senior citizen. In the we are using the strip plot to perform the bivariate analysis. On the x-axis we are using the senior citizen. That's why here the 0 and the 1 values are there. For the y, we are taking the tenure of the column, and data is equal to df. Now here you can see if we are checking, then the tenure for the non-senior citizen and for the senior citizen is almost same. But if you check the dots here, basically this is representing the density. So the density of the senior citizen, those who are not senior citizen, their count is high as compared to the those who are senior citizen. That's why here we have mentioned that there is no significant difference between the features. Here both the features are in equal length, because the tenure you can see almost same for non-senior citizen and for the senior citizen. The lowest value is 0, it is almost 0, 70, 70, right? Okay. Then after that, here we are using again we are doing the analysis between two different plot. First one is tenure, second one is total churn, and here we are using the sns dot scatter plot. Scatter plot is basically used to find out the relationship between two continuous column, but you can also use between two categorical column by changing the values of the categorical variables, right? So here we are using the scatter plot to find out the relationship between the tenure and the total charges column. Data source is basically df, that is my original data frame. Hue is equal to char. Hue is basically the third parameter here. It is representing the third parameter that is basically used to give the color code. If I want to find out the relationship based on the third parameter and I want to represent them into the different colors, then we write that column in the hue column, hue parameter. Palette is basically is equal to bright and plt dot show. So here if you are checking the relationship here for the 10 year, the 10-year range is basically 0 to 70, and the total charges is basically in the range of 0 to 8,000 plus, right? That is basically, you can see if the difference is 2,000, so the maximum value is 10,000. Now here you can see it, just because of the hue, in the hue we have given the churn column, so that's why there are two possibilities in the churn column, that is yes, no and yes. The no is basically represented by blue color and the yes is represented by the orange color. Now if we are checking this graph, then we can find out that okay, the relationship, okay, the relationship between the 10-year and the total charges is basically linear, means if the 10-year is increasing, the total charges is also increasing. But we have checked that when the 10-year is very less, at that time the attrition rate, means the orange colors are very high, whereas when the 10-year is around 70 and the total charges is also high, at that time the 10-year is basically the churn rate is very less. Okay, so what we have mentioned, that here we can notice that the strong relationship between the feature, strong means positive relationship, if one is increasing and there is also increasing, as the tenure increases, the total charges also increasing rapidly. If the customer have low tenure services, if the customer has low tenure services, then there is a high chance of churn. Why? Because here the yes churn rate is, the values is very high as compared to the when the tenure as well as the churn rate is high. Clear? Okay. Now in the same way we are using the bar plot to find out the relationship between the gender and the senior citizen. Okay, someone is asking, sir, is it mandatory to find out the relationship between all the features? Yes, it is mandatory. Okay, because if you are doing the analysis, then analysis must be performed on whole data, not on some selected particular data, right? First we have covered the numerical columns, right? There are four numerical columns, we have checked the relationship between them, we have checked the value count function, right? Again we are also going to check the other values, but during the univariate analysis we check the distribution of the plot and so on, right? We have also checked the value count function for the categorical column. But whenever you are doing analysis, you must have performed the analysis between different columns, okay, and for different columns, because in this way you are going to get more insights from the data. Now the question comes, okay, just wait, what is the question? Just wait. Okay. Okay, the question is how many plots should be used? So basically there is no limit. Okay, I cannot say that whether you should use this particular graph, whether you should use only this number of plots. Okay, this is not a limit here. Okay, you can use any plot and you can use any number of plots. You can use plot between any feature based on your analysis. But if you are using very less number of plot, then definitely you will get very less information about the data and you will make decisions, you will make mistakes while making the decisions about the data, and it will lead to either overfitting or the less performance. Okay, the performance of your model will be less and you will be worried, sir, I have checked the skewness, I have done this, I have done this, still I am not getting the high accuracy. So basically you are not getting the accuracy because you do not have the information about the data, and that's why you are making a decision that is affecting the performance of your model in a negative way. Clear? So that's why try to use more graphs. Okay, and the graphs must be used based on the type of the data present there, what kind of analysis you want to perform. Okay, what is the use of a particular graph. Okay, if you do not know how to use a particular graph, what is the use of particular graph, right, what is the advantage and what is the disadvantage, then definitely you may face difficulty to select a particular graph to be used for any particular kind of data. Clear? Okay, so here we are using the bar plot between the gender and the senior citizen column, and again in the U we have written the churn. So here when I am writing here, so here you can see the gender is basically male, male and the female. Again in the female there are two categories, first one is churn and second one is non-churn. For the male again there are two categories, churn and no churn, right? Now if you check the churn rate, okay, the churn rate in female as well as in the male is almost same. In the same way, non-churn rate is almost equal. So here we have mentioned that there is no significant difference between the columns. The customer churn remains unaffected in gender and senior citizen case. Okay, doesn't matter whether they are senior citizen or whether they are what is the gender, they are unaffected. Okay, in the same way, we are doing the comparison between the total charges column and the monthly charges column. Again, in the U, we are considering the target variable. Okay, and here you can see the total charges in the range of 0 to 10,000, and the monthly charges column is in the range of 0 to 140. Okay, now or 120, right? Now here you can see when the total charges are high. Okay, when the total charges are high, sorry, when the total charges are low and the monthly charges are high, then at that time the churn rate is high. Okay, but whereas when the total charges column is high as well as the monthly charges are high, at that time the churn rate is low. Okay, means the less number of customers are basically churn. Now here you can see as the total charges is increasing, the monthly charges is also increasing. So again, there is a positive linear relationship between the monthly charges column and the total charges column, right? Again, we have mentioned that there is a linear relationship between the features. The customer who with high monthly charges have high tendency to stop the services. Okay, high monthly charges, because here you can see when the monthly charges was high and the total charges was low, at that time the churn rate was high. Clear? To stop the services, then since they have high total charges, also if the customer ready to contribute with the monthly charges column, then there is an increment in the total charges. Clear? Okay, then after that, here we are again, we are checking the cat plot. Again, we are using a new kind of plot, that is basically cat plot between the churn and the gender column. Okay, and here the kind I'm using the count. Okay, because in the cat plot there are different parameters are there. If I'm using the kind is basically what kind of operation I want to perform. If I'm writing kind is equal to count, it means my cat plot will check the count of the values. It will work as a count plot. Clear? That's why here the kind is equal to count. If we are checking here, then you can see in the phone services there are two possible values, right? Again, there are two possible values in the phone services. First one is, okay, just wait, this is not phone. Okay, first column is gender, right? First column is gender and the churn. So in the gender there are two possible values, gender female and gender male. Then after that, again in the churn there are two possible values, yes and no. So for the female, first it is checking what is the count of no, what is the count of s, right? So the female, the customers, those who are female, the churn rate is around 2500, whereas for the non-churn, okay, sorry, non-churn rate is basically around 2500, whereas the churn rate is around 1000. In the same way, we are checking for the gender for the male. Clear? In the same, we are checking for the for different columns, right? So I'm not going to discuss about all the columns, but here I have mentioned few observations, right? In the first plot, we can see there is no significant difference between the customers, between the genders. Both the genders have equal churn level. In the second column, we can see the customer without partner have high churn rate compared to the customer with partners. Okay, so in the same way, you have to apply different kind of plot between different kind of features, right? I'm not going to discuss all of them because it will take more time and I have to stress the time of the session, right? Now, then, so it is basically all about the multivariate analysis. So in the multivariate, sorry, in the bivariate, it is all about the bivariate analysis. So basically in the bivariate analysis, we are doing the analysis between two columns, right? So I'm scrolling down just so that you can see the code, you can see the observation, and later you can watch the recorded video and you can learn about them, right? Because if I'm going to explain each and every code, then it will take a lot, like much amount of time, right? So I'm not doing that. Okay, then after that, after completing the bivariate analysis, we are moving ahead for the multivariate analysis. Multivariate analysis means when we are doing the analysis by considering more than two or three columns. Okay, okay, scroll down. Okay, just wait. Wait. Okay, we have discussed till that. You are saying just scroll slowly, right? You can basically change the speed of the session as well, right? So it will not be a problem if you want to pause the video. Okay. Okay, done. Okay, so whenever we are talking about the multivariate analysis, so multivariate analysis means when we are doing the analysis between more than two columns. Okay, means three or more than three columns. So here for the multivariate analysis, here we are using the SNS dot pair plot. We are considering the whole data frame, right? But if the pair plot is basically used to find out the relationship, so by default it will select only the numerical columns, but it can also select all the columns. Okay, but if you want to apply between the continuous column, then in that case you can use the ilog function, you can use the log function, or you can use any other method to select any particular set of columns. Okay, so here I'm using df, and here again I'm using the hue is equal to chun and palette is equal to dark. Now here you can see there are only one, two, three, four. Okay, there are only four columns, right? First one is senior citizen 10 year. Then after that, it is also giving monthly charges column and the total charges column, right? So whenever we are using the pair plot, so basically the pair plot is used to find out the relationship between the features by taking them as a pair. Okay, so if I'm saying the senior citizen, it will first check. Okay, it will first check the distribution of the plot, because in okay, because in the diagonal you can see it is all about that distribution of the plot, right? So how the senior citizen data is basically scattered. Then after that it is finding out the relationship between the senior citizen and the tenure. Then after that it is finding out the relationship between the senior citizen and the monthly charges column, senior citizen and the target value, and the sorry what total charges column. In the same way, tenure is finding out the relationship between the tenure and the senior citizen. Then after that we are checking the how the data is distributed. So here you can see the blue one is basically representing the non-churn, and the yes is basically representing the churn rate, right? So for the 10 year you can see how the what is the distribution of the data of the customers who have churned, what is the distribution of the data who have not churned, because the last time we have used the dist plot, at that time it was giving one plot that is basically a combination of both the unique values, right? But here what we are doing, here we are deciding, here we are checking the values based on the unique values. So for the 10 year, the unique values means based on the target variable unique values, how they are making the difference here, right? Then after that it is finding out the relationship between the 10 year and the monthly charges column, that is also a positive relationship. Again the 10 year and the total charges column, in the same way monthly charges column is doing the same thing, right? So here we have given the observation. What is the observation? The pair plot gives the pairwise relationship between the features on the basis of the target variable, that is our churn rate. On the diagonal we can notice the distribution of the data, right? That is basically we are checking the distribution of the data by using the dist plot. So pair plot has inbuilt the dist plot, that is basically giving the information, right? The feature, tenure and the total charges column, monthly charges and the total charges column have a strong relationship with each other. Okay, because here we have checked the tenure and the total charges column. Then after that monthly charges and the total charges column has the strong relationship. Clear? There are no outliers in any of the column, but we will plot the box plot to identify the outliers, right? Now what we are doing, we are again using the same for loop, plt dot figure size 10 6 face color is equal to white plot number, but here we are using the box plot. Okay, box plot. Can anyone please tell me why we are using the box plot and which mathematical function is working behind the box plot? Please let me know. Okay, Vijay Kumar, your answer is basically correct. Okay, someone is saying box plot is used to find the outliers. Okay, to find outliers. Okay, that's great. Avilash, your answer is also correct. Okay, so basically, the box. Okay, Bipulanand, you are giving the exact uh, equation, right? Okay, that's fine, no problem. So basically, whenever we are talking about the box plot, basically the box plot is used to identify the outliers. That's correct, right? But it is using the interquartile range method to find out the outliers, right? So how? Because here you can see whenever you are checking the box plot, there are different values. First one is this is the minimum value. This is the first quartile. This line, middle line, is basically second quartile or the median of the value. This is the third quartile, and this one is the fourth quartile. So if any value data point that is basically present not in the range of this value, that is basically that is present outside the minimum value or the maximum value, right, that is considered as an outlier. And there is a equation of the for the interquartile range, right, that we will discuss later. Now here you can see, here we are checking for the senior citizen column. So basically this single line is basically the whole, it is whole, but just because there is a very less range, that is basically 0 to 1. So that's why here you can see there is a one outlier. This the round symbols or any other symbol is basically representing the outlier. So we can say that, okay, in the senior citizen column there is an outlier. For the tenure, you can see there are no dots or the round symbols are there, so there are no outliers. In the same way, for the monthly charges column, there are no outliers. But here in the total charges column, here you can see there is a huge difference between the third quartile and the maximum values, right? But still there are no outliers are present, right? That's fine. So here we have mentioned that the column senior citizen has outlier, but it contains the categorical data. Now I am saying it contains the categorical data. Please listen carefully, because as per our output, as when we checked the data type at that time in the senior citizen column, there were two values, two numerical values, that was basically 0 and 1, and we considered that column as a numerical value. But now I am saying this column contains categorical data. So which one is correct? Whether it contains the categorical data or the numerical data? Please let me know. Okay, Kriti, your answer is basically correct. Okay, Chandan Rai, you are saying both as it is binary classification. So basically, if the binary values are present in independent variable, then there is no meaning of it, right? Okay, someone is saying categorical data. So it means you are saying this is not a numerical data. Okay, we have to convert other categorical data in numerical form. I am not asking about that part, right? Okay, so basically those who are saying both are correct, because this data is numerical as well as the categorical data. Okay, so the categorical data does not mean that when that values in a particular column is a string. Okay, means the categorical data means when the data is present in the categories. I have asked about the numerical and the continuous data, right? Some of you are saying continuous data, something with then when there is an indefinite number of values in a particular range, right? But whenever we are talking about the data frame, okay, the case is different. How? Because if the data. For example, there is a gender column, right? In the gender column, there are two values, male and female. Now the data is present in the string format. That's why you are saying there are two categories. But instead of the male and female, I am writing 0 and 1. Then it is a numerical data as well as the categorical data, because the data is divided into two categories, 0 and 1. And that what we are going to do, because we are going to convert the string data into the numerical data, because our model, our machine learning algorithm does not understand the string data. So you have to convert into the numerical data. Now the question is, what is the difference between the numerical data and the category and the continuous data? All the data that is basically present is continuous. Sorry, all the continuous data is basically a numerical data. For example, in a particular column, okay, total 10,000 entries are there, means 10,000 rows are there, okay, in a column, and there are float values are there, okay, means there are float values, means the decimal values are present in all the columns. There are no null values, there are no string data, there is no white space, only the float values are there, okay. But the count of total number of unique values in that particular column is only 15, means out of 10,000 values there are only 15 unique values are there. Then that data is a categorical data, not a continuous data, okay. That is a categorical numerical data. Why? Because the whole data, that whole 10,000 data is divided into 15 categories. That's why there are only 15 unique values. And when there are only 15 values, it means the same value, those 15 values are repeated several number of times. The count can be different for each unique value, but the same values is repeating number of times, right? So that's why that is a categorical data as well as the numerical data. But in the total charges column, the total number of unique values were 6,531 out of 7,043. So if you check the difference between the total number of values and the total number of unique values are very less. The difference is very less, right? And just because if the difference is very less, then we can say that in the total charges column, right, continuous data is present. For the monthly charges column, the number of unique values 1,585, right? Again, it is a continuous. Why? Because see, if I'm saying the difference is high, yeah, difference is high, but the total number of unique values, how? 1,600, right? That is basically 1/4 or 1/5, right? Again, this is a continuous data. But in the senior citizen column, the total number of values are 7,043, out of which there are only two possible values, that is basically 0 and 1, okay. The number of unique values are very less. Then this is a categorical data. Clear? So this is the difference between the categorical and the continuous data. Okay, someone is saying, so we do not need to delete the categorical column data. No, we do not need to delete the categorical data. If you are removing that data, for example, if the gender is there, okay, and we have checked the here wait, okay, we have used this graph, right? If we are going to remove the categorical data like gender column, then why we are doing this analysis? For example, you have checked there are different companies, there are different services by the government. They are launching the services only for the women's, only for the men's, right? Only for the men, right? Only for the women, only for the children. So how they're categorizing? Even they are introducing some facilities for transgenders, for senior citizens. How they are doing that? If they are removing the categorical data, if they are removing the categorical data, then it is quite impossible for me to launch any kind of product or any kind of service for any particular kind of category. Because here you can see, I can know that, okay, for the churn rate for the female, the number of customers, those who have not churned, okay, their count is high. So I can find out, okay, the female customers are loyal. I will give more services to them. I will give more offers. Okay, in the same way for the male, the count is almost same, but if the count is different, then I can differentiate it, right? So it is not mandatory to drop the categorical columns. If we are going to drop the categorical columns and we are not feeding the categorical data to our model, then how our model will not understand the difference between the categories? It will not, my model will not understand, and that definitely whatever the performance given by model will be biased, and I cannot use for any particular kind of category. Okay, so we do not remove the categorical data from the data frame or from the data. Okay, clear? So what we are doing here I have mentioned that, but just because it contains the categorical data, so we are not going to remove the outliers. Okay, because we do not remove the outliers from the categorical columns. Why? Because we are checking the quantile values, Q1, Q2, Q3. Then we are checking the IQR by taking the difference between third quartile and first quartile. If we cannot count the quantile, then how we can remove the outliers? Okay, and always remember that whenever we are talking about the categorical data, then the categorical data are independent with each other. Okay, they are not dependent with the values. If I'm saying male and female are dependent, no, they are not dependent. If I am a male customer, you are a female customer, so are you relying on me or I'm relying on you? I'm totally independent. It's my choice how what like I want to take a subscription of which company, right? What should be my monthly charges? What should be my total charges? So company cannot decide any offer based on your uh, interest or based on my interest. Clear? Clear? So you need to understand that. That's why we do not remove the outliers from the categorical columns. Or we can say, okay, we do not remove means we do not detect the outliers from the categorical columns. Again, I'm saying we do not detect the outlier from the categorical columns, but we detect the outliers from the continuous column. If the outliers are present in the continuous column, then we will use the suitable method to remove the outliers. And to remove the outliers, if we need to remove the whole data from all the columns, means from whole data set, then we will do that. But we will not use any method to detect the outlier from the categorical columns. Clear? Okay, then after that we are checking for skiffness, and for that we are using the df.skiff. Again, here for the senior citizen it is 1.833, for the tenure it is 0.22, for the monthly charges it is 0.22, again negative 0.22 for the total charges. Now here you can see that the skiffness value, right? So if I am saying what is the acceptable range of skiffness value, so basically the default skiffness value is negative 0.5 to positive 0.5, but it is not mandatory to take this range, because the skiffness is basically based on what data is present inside the column. Okay, but we always try to remove the skiffness, means we always try to get the skiffness value should be 0, because the 0 means the data is in bell shaped curve and the data is there is no skiffness, or you can say there is a symmetrical data, right? But it is very hard to achieve the symmetrical data in real life. So what we are doing, we are taking a default value, that is negative 0.5 to positive 0.5, right? But again I'm saying it is not mandatory to achieve this score as well. So what we are doing, we are applying different transformation method. Different transformation method means transformation method like square root, logarithm, logarithm plus 1, right? Cube root, box cos, power transform, some method say such methods to remove the skiffness from a column. after applying the skiffness, it is not mandatory that the skiffness will be removed completely, or it will be in a acceptable range. If it is not in acceptable range, then again we will apply another skiffness method on the original data, and we will see again the skiffness value, right? If after applying several methods, if the skiffness is not removing after an extent, then we will consider that particular value as our threshold value, right? But whenever you are doing on a project, you have, if you are applying more than one transformation method, then all the methods with the output must be present in your file. Otherwise, if you are making any claim, I have used several methods but I'm not getting the skiffness value below that, then we will not consider your claim as a valid claim, and directly we will deduct the marks. Because to for a valid claim, you must have the output along with the code in your notebook. Clear? Now, in the senior citizen column, as I told you that the acceptable range of skiffness is basically negative 0.5 to positive 0.5, and here we can see for the total charges column, it is not in the range because it is greater than 0.5. For senior citizen, it is greater than 0.5, but for these two columns are basically in the acceptable range, right? Now, again, there is a case of senior citizen. Senior citizen is a categorical data. Again, if there's a categorical data, we cannot calculate the mean and median. If we cannot calculate the mean and median, then we do not remove the skiffness from the categorical data. Again, we are not going to remove the skiffness from the senior citizen column, but we will remove the skiffness from the total charges column. Why? Because the total charges column has the continuous data. Okay, and to remove the skiffness, here we are using the cube root method. So what we are doing, we are using np numpy dot cube root on the total charges column, and after making the changes, we are storing in the same column, right? And after removing the skiffness, again we are checking the skiff, we are applying the skiff method to check the skiffness value, so that we can find out whether the skiffness has been removed from that particular column or not. After checking, here you can see the skiffness value is basically 0.01. That is basically much closer to 0. It means the data is almost what, symmetrical, or almost in a bell-shaped curve, right? So here we have mentioned that we can see the skiffness has been reduced in the total charges column, and it is in acceptable range. To confirm the same thing, again we will use the dist plot, right, on the total charges column, and here you can see in the total charges column, all the values are in, basically it is, the skiffness has been removed. Clear? The skiffness has been removed because the chart, if you check this, it is almost in the bell-shaped curve. Clear? And here you can see that values are changed, right, in the total charges column, because the skiffness, the transformation methods basically transform the values in such a way that the skiffness must not be present. Clear? Okay. Now, then after that, as I mentioned earlier, we have to encode. Okay, we have to convert the categorical values into the numerical values by using the encoding techniques, because the categorical data is not understandable by the algorithms. Okay, so for that, what we are using from sklearn.preprocessing, and we are importing the ordinal encoder, right? Then we are initiating the ordinal encoder and storing in the variable named OE. Then after that, we are using the for loop that will iterate over the index of the columns of our data frame. And if the data type of our column is object, then we will apply the fit transform method. Now you need to understand that the fit transform is basically a combination of two different methods. First one is fit and second one is transform. Earlier there was two methods. First one is fit. So during the fit, what we were feeding the data, the model used to use the method used to find out the patterns, used to find out the insights, right? What is the variance, what is something more information, and based on the information, when we were using the transform, it was changing the values instead of finding the information again, right? So by combining the fit transform method, it is created. right? So here we are using the df.i.values.reshape because we are reshaping the values, because after applying it will be converted into the the array format, right? So what we are doing again, we are applying the ordinal encoder to encode the values from categorical to categorical, means from object to input value, integer value, right? So here if you check for the gender column, earlier it was male, female, and so on. Now the values has been changed from 0 to 1 and 1 to 0. Clear? In the same way, senior citizen, nothing. For partner, change the values. Dependent values are changed. Phone services, multiple lines, internet services, online security, online backup. Even for the churn value, the values has been changed, right? After changing the value, again we will check the information, and when we are checking the information of the value, then here we are checking float, and for the 10-year and for the partner column the data type is integer. Now if you check here, so here you find we will find out that there are 18 columns with the float 64 data type, and that there are 2 columns with the int 64. Clear? Okay. But ordinal encoding gives order to data like low, medium, high. That's correct. The ordinal encoder is used to give the order, right? But I'm not suggesting to use the ordinal encoder, right? You can select the encoding method based on what kind of data. If the nominal data is there, you can apply the one hot encoding. You can apply the pd.getDummies, right? If the ordinal data is there, you can use the ordinal encoder. You can use the label encoding, right? But you cannot use the one hot encoder. Okay, one hot encoder is more useful. It is not mandatory. Again, I'm saying, you are saying one hot encoder is more useful. I'm saying this is not mandatory. Why? Because based on what kind of values are present in a categorical column, we are deciding the encoding method. Every encoding method has some drawback, has some advantage. So you have to check the encoding methods, right? Here I'm just giving one demo. You can apply the this method. Okay, but if you are using the ordinal encoder, you are saying the order, but just but here you can see most of the column has only few like 2 values, right? So in case of 2 values, I can use the ordinal encoder, right? Now in the same way, for example, in my target variable, in the target variable all values are independent, there is no order. Okay, yes or no, there is no order. But if I'm applying the one hot encoder, okay, in the if for the target variable I am using the one hot encoder, so then what the one hot encoder is doing, one hot encoder is basically adding the number of features in your data frame based on the unique value present in a column on which you are applying the one hot encoding. So in my target variable there are 2 values. First one is chun. Sorry, in the chun column there are 2 unique values, no and yes, right? So if I'm applying the one hot encoder on the target variable, just because it has nominal data, right? So for the nominal data we are using the one hot encoding, right? If I'm applying, then 2 variables will be added, 2 columns will be added. First one is for no chun, second one is for yes chur, right? But in a data there can be one target variable at a time. So if I'm going to build the model, will I select the no churn or I will select the yes churn, right? So I cannot apply the pd.getDummies one hot encoder, right, for the target variable. So based on the situation, based on the kind of the data, we are applying the methods. Okay, that's why I'm saying there is no straightforward rule here. There is no straightforward set of instructions. There is no straightforward set of methods that must be used. Everything must be used based on your analysis, right? At the very beginning of the project discussion, today's project discussion, I have clearly mentioned that, because machine learning is all about the hit and trial methods, right? So those who are thinking whatever the sir is teaching, I am going to repeat in the same manner. If you are repeating in the same manner without any valid reason, or with half information, you are not doing the proper analysis, I will give you 0 marks directly, because we do not entertain the plagiarism as well as the copy pasting. Okay, the projects must be done by you based on your knowledge. And that's why if you calculate from today, if you count from today, I am giving you 10 days. From this Sunday to next Sunday I will conduct one more session, then after that I will give 3-4 more days. So you can say you can like you have around 10 to 12 days to revise everything. Revise. If you need any kind of help, that is basically covered by your institute, you can connect with them, okay, through their forums. If you need any kind of help that is basically being discussed by me or by us, you can raise a ticket. Clear? But do not use the exact code, the exact logic to solve each kind of problem statement, because I know most of you are those who are not active on the chat and they are just attending the session. They are going to use the same method. They are going to watch the dummy session and this project discussion, and they will repeat the exact methods, exact steps for all kind of problem statements. Okay, because see, you need to understand that when the data is different, then the story will be different. If the problem statement is different, the data will be different. If the data is different, the story will be different, right? If the story, data, problem statement is different, then how you can say that for every problem statement, same set of instructions, same set of steps will be used? Okay. Okay, now again we are checking the describe of the data, and here you can see it is considering all the columns here, right? Now we are moving ahead and we are checking the correlation. Correlation is basically to find out the relation between the variables, right? And the range of the correlation values -1 to +1, right? -1 to +1 here. So here we are using the df.core function. The df dot is the dot core function is basically present in the pandas. Okay, that is basically used to find out the relationship. Okay, that is used to find out the correlation value between the variables. Now if you check here, here you can see it is finding out the relationship between pair of columns. So for example, I want to find out the correlation value between the dependent and the gender. Then how we can find out? You need to check where this particular row and this particular column is intersecting each other. So basically the dependent and the gender means first row, fourth column is intersecting at this place. So the correlation value between the dependent and the gender is 0.015. I can say that okay, there is no correlation. Okay, correlation means how they are related, means if I'm making changes in one column, then how the other is affecting. Okay, how the other column is getting affected. If it is not getting affected, it means there is no correlation. So the correlation values in the range of -1 to +1. -1 is basically representing perfect negative correlation. +1 represent perfect positive correlation, and there's a value that is known as 0. 0 means there is no correlation. Sorry, there is no correlation. Okay, now what is the meaning of -1? -1 means if there is a -1 correlation value between two columns, it means if I'm changing, if I'm making a change in a particular column, then in another column that is correlated, it is affecting in a same manner but in a negative way. Okay, so there are three values are there. Yeah, like heat map, you can use the heat map. I'm going to use the heat map for the correlation function as well. Okay, but I'm teaching you how to find out the correlation value between the columns. For example, I want to find out the correlation value between the tenure, okay, and the multiple lines. So here the multiple lines is there, right here, and the tenure is there, right? So here the multiple line and the tenure is intersecting at this point. So basically here the correlation value is 0.34. So we can say that okay, there is a low correlation between the multiple lines and the tenure column, right? So it is quite difficult for here, right? So what we are doing here, and also it is not uh, I can say if we are finding out the relation, it is quite confusing here. So what we are doing here, we are using the heat map. Okay, and for the heat map, what we are doing, first we are deciding the size of the figure. Okay, then after that we are using the heat map and correlation function. We are lying line width, right? How many values are there? FMT is 1.0, means how many decimal values are allowed, right? After how many values are allowed after the decimal point. Then after that not is equal to true, so that we can see these numerical values on color, okay, on this graph. Otherwise it will only give the color representation. So here you can see for the dependent, right? Here you can see for the gender in the diagonally, basically they are finding on the relationship within themselves, right? But here you can see based on the color code, the color code is basically starting from negative 0.4 to positive 1. Okay, so here we can see the positive 1, that is basically closer to 1, is represented by white color. So here we can see for the 10-year and the total charges column, the correlation value is 0.9 for the 10-year, and for other column negative 0.4 for 10-year, and the contract it is 0.7, right? So basically in this way we can find out the correlation. Now the concept, what is multicollinearity? Multicollinearity means, see, first of all you need to understand that whenever we are checking the correlation value, so basically we are checking the correlation between the features, means between the independent variables, as well as we are checking between the independent variable and the target variable. So basically here you can see our target variable is churn, right? So here for the total charges column, you can see negative 0.2, 0.2, 0.1, negative 0.4, negative 0.3, negative 0.2, negative 0.3, negative 0.04, 0.5, 0.05, negative 0.5, 0.2, right? So here you can see this is basically the correlation value between the target variable and for the columns. So after from the observation, we can find out that okay, there is a highest negative correlation value is 0.4 and highest positive correlation value is 0.2. Okay, now whenever we are checking the correlation, we are finding out the correlation, right? So if two or more than two independent variables are highly positive or highly negative correlated with each other, then that is a case of multicollinearity. But if a particular independent variable is highly uh, correlated with the target variable, then it means that particular column is contributing more towards the prediction of your column, of your target variable, means that is an important feature. Okay, now here we can see the 10-year has a high positive correlation with the total charges column, and both are independent columns. So we can say that okay, there are possibility that there are multicollinearity. Okay, now we are writing the observation. Okay, here 0 means no correlation, negative 2, positive 0.3 is less correlation, greater than negative 0.5 or greater than positive 0.5 moderate correlation, and greater than negative 0.7 or greater than positive 0.7, it means high correlation. Clear? Now the heat map shows the correlation matrix. By visualizing the data, we can observe the relation between the features to feature, right? Now what are their heat map contains both positive and negative correlation. There is no much positive correlation between the target variable and the feature, because the highest one is 0.2, right? The column monthly charges, paperless billing, senior citizen, and payment method have positive relation, and the remaining have negative correlation. The column gender has very less correlation with the label, and we can drop it if necessary. Okay, if necessary. Then after that, the column total charges and 10-year, contract and 10-year, total charges and monthly charges, and many other columns have high correlation with each other. So this is a direct indication that there is a multicollinearity issue, right? Now we are using the core function on the churn rate. Okay, and we are sorting the values ascending is equal to false. Okay, so here we are checking the maximum value. So maximum possible value is 0.19, right? And negative one you can see here. So basically negative one is negative 0.396713. Okay, now you can also see this graph by using the bar plot, right? Now we have confirmed that there is a multicollinearity is there. Okay, and there are few columns that has the very less correlation. So before proceeding ahead, we are we are basically dividing our column into two parts, our data into two parts. First one is independent variable, second one is dependent variable. Okay, so what we are doing, we are using df.drop, and we are dropping the churn column from the data frame because we want to store the independent variable in the x variable, and in the by variable we are only storing the churn variable. Okay, now we have separated the data into two parts, features and the label, or you can say independent variables and the dependent variables, right? Then after that we are going to use the scaling methods, okay, so that we can remove the biasness, right? Scaling method is basically used to transform the value in such a range that all the values must have on the same page so that there should be no biasness. Clear? Okay. Variance inflation factor is also used told in the class. That's correct. We are going to use the variance inflation factor. You can use, you can directly drop. You can also use the PCA, that is principal component analysis, to handle the multicollinearity. But I have not removed the multicollinearity yet. I have just find out whether there is a multicollinearity or not. Okay. Now, then after that we are using the scaling method so that we can scale the value, and for that we are using the standard scaler. You can also use the min max scaler, that is also known as the normalization, right? So here we are using the scalar method and we are using the fit transformation, and we are applying the scaling method only on the features. Basically we apply the scaling methods on the continuous data, but if you are applying on the categorical data, there is no impact because the categorical data is already in a range, right? Then after that, column is equal to x column, because whenever you are using the standard scalar method, it is storing the data in a array format, right? So you have to again convert into the data frame, right? One more thing, we do not apply the scaling methods on the target variable, because if you are transforming, means just remember that we do not perform any operation on the target variable that change or modify the values of your target variable. Okay, even we do not remove the skewness, we do not remove the, we do not detect the outlier from the target variable, we do not apply the scaling method on the target variable, we do not, if the null values are there, we directly drop it, we do not replace them, because we do not transform or modify the value of our target variable. Clear? Okay, now after the variable, after applying the scaling method, you can see the values has been changed in certain range, right? Then after that, we have mentioned that we have scaled the data using a standard scalarization method to overcome the issue of biasness, right? Now someone was mentioning about the variance inflation factor, so now we are going to use the variance inflation factor. Before using the variance inflation factor, please remember that we are applying the variance inflation factor only on the independent variable, because the multicollinearity is present within the independent variable, not between the target variable, or not with the target variable. Clear? Now, what is the formula? The formula to find out the variance inflation factor is basically 1 divided by 1 minus r squared value. Clear? So what we are doing, first we are importing the stats model dot stat dot clear influence, import variance inflation factor. We have imported that. Then after that, we are creating a empty data frame, right? Then after that, what we are doing, we are using the for loop that will basically check the that will iterate over the columns of independent variable. Okay, and it will, whenever we are finding the where during each iteration, it will apply the variance inflation factor to the x dot values, means the values of the variable. Okay, and for each column, right? And whatever we are doing, we are storing in the same data frame, right? After that, we are finding out VIF value features 1.0, some values are there, right? Now the question is, what do you mean by VIF value? Because see, the minimum VIF value is 1, and when the VIF value for any particular column, for example this gender column, the VIF is 1.000, right? So basically it is very closer to 1. Now what is the meaning of it? The meaning of the gender column, the VIF value for the gender column is 1. It means this gender column is, okay, this gender column is not correlated with these remaining column. Okay, this gender column is not correlated with the remaining independent variables. Okay, if I'm saying the 10-year has 12.3 VIF value, what does it mean? It means the 10-year column has 12 times the multicollinearity of with the remaining column when there was no multicollinearity. Clear? Okay. Okay. See, now the question is, someone is saying the if we are checking the 5 as the threshold value to remove the multicollinearity by using the VIF factor, but that is not the case. Always remember that that is not the case. In general, we are taking 5. Okay, but in real life we are taking 10 as well. If the VIF value is greater than 10, we are removing it, right? But there are certain cases where if you are considering 5 or 10, okay, you are going to remove whole data. Okay, that can be handled by the regularization methods, but we are not removing the we are not removing the multicollinearity by using the VIF by taking the 5 or 10 as the threshold value. If here you can see all the values are basically in a range of 1 to 5 or 1 to 16. So in that case, we can say that, okay, we are taking the 5 as the threshold value or 10 as the threshold value. For example, here I am taking the 10 as my threshold value. Okay. But here for all the VIF, for all the column, if my VIF value is greater than 100, in that case, I cannot take 5 or 10 as a threshold value. If I'm taking, okay, if I'm taking, then first of all I have to remove the column that has the highest VIF value. After that I have to check whether after removing that one how it is affecting. If they are coming in the range of 1 to 10, 1 to 5, whatever the threshold value you are taking, then in that case I can say that okay, the threshold value should be 5 or 10. Okay, so for example, here if I'm taking the 10 as my threshold value, okay, for the VIF, so there are 2 or 3 columns. First one is tenure column and the second one is total charges column, where the VIF value is greater than 10, my threshold value, right? So it means if there are 2 or more than 2 columns that has the threshold value more than your that has the VIF value greater than your threshold value, then you should remove the column that has the highest threshold value. So here there are 2 columns, 10 year and the total charges column. Out of these 2 columns, 10 year total charges column has the highest VIF value. So we will drop the total charges column. Okay, we will drop the total charges column and we are applying the access equal to 1 because we are performing the operation column wise and we are making changes in the X data frame. Clear? After that we will again check the value VIF value, and when we are checking the VIF value, you can see the 10-year column is basically the value of the VIF value of the 10-year column is decreased. Why it is decreased? Because maybe the value of the 10-year column is increased because of the total charges column, and during the heat map we have already checked that the correlation value between the 10-year and the total charges column was 0.9 or 0.7, something like that, right? So just because they were highly correlated, if one of them is removed, that's why the VIF value is changed. Now here we have checked that for the monthly charges column also the VIF value was 5.38, but after removing the total charges column, the monthly charges VIF values decreased to 2.73. Clear? So in this way we are removing the multicollinearity. Okay, now wait a minute. Okay, just wait a minute. So here we have mentioned that, okay, so we have solved the multi-collinear ratio, and now we can move ahead for the model building, right? Now again we are checking the value count function of the target variable, and in the target variable my churn rate is there. That's why here you can see the name of the column is churn, right? Now here you can see y dot value count function. There are two possible values. Two unique values are there, 0 and 1. For the 0 it is 5.174, for the 1 it is 1864, right? So it is clearly indicated that the data is divided into basically 60 or 70 ratio, say 70 and 30 ratio, or 80 and 20 ratio, right? You can calculate it. Now so this is basically a case of class imbalance problem, and to handle this case we are going to use the sampling method, or you can say resampling method. Now what are the resampling method? There are different resampling methods: oversampling, undersampling, random oversampling, smooth, near miss, right? There are so many sampling methods are there, but every method has different use. Okay, every method has a different advantage and disadvantage. For example, if I'm using the undersampling, here you can see the minority class values has 1869. For the majority class it is 5174, right? If I'm applying the undersampling, then it will decrease the count of the majority class and it will make equal to this one. In that case the data loss will be more, right? I cannot do that. If I'm using the oversampling, then it will populate that duplicate data of this column to equal this value. Again the duplicate data will be there, right? If I'm using the random oversampling, then again the case will be different, right? So we can use the smooth method. Why? Because this is a synthetic method that is using the random oversampling, right? You can use that one. In that case it will generate some data by using the random oversampling. Okay, now so what we are doing, we are doing the same thing. Okay, okay, someone saying, okay, we were taught only smooth and near miss. That's fine. Okay, you can learn about different methods. See, if you are saying your institute has taught you only few methods, so let me tell you, it is quite impossible for any institute, even for our company or for any company, to teach you everything. Why? Because every day new methods are introduced in the market. Okay, and even whatever they are teaching and whatever the projects we are doing, whatever the technologies you are using present day, you are not going to use in the future, right? So again you have to learn so many things. Okay, so your learning phase is not over yet, it will be forever. Okay, if you really want to make a good career, then you have to be flexible to learn new technologies, new methods, right? So whatever the methods are there, they are modifying day by day. They are making changes in the syntax, right? Okay, someone is saying VIF applied before scaling or after scaling. You can apply both the approaches, right? First apply before scaling and uh, build the model. Again check the performance of the model. Again you can first apply the scaling method, then do that. Again check the performance of the model, because see, whatever the steps are performing, everything is impacting the performance of your model, right? So you have to use in different way, right? Okay, now here we are using a smooth method. Okay, sm dot resample, and in the resample we are here sharing the independent feature and my target variable, because I want to balance the classes within the whole data set. Okay, then after that I'm storing in x1 and y1. So earlier the ratio was different, now the ratio is equal, because the number of the count of each class is 5174. Clear? Okay, before moving ahead, let me tell you what we have discussed. Basically we have read the problem statement, then after that we learned what is most important, then we learned about we imported the libraries that was required, then after that we checked the data, we did the non-graphic analysis by using head method, information method, describe method, right? Means where we were not using the graphs. Then after that we completed the graphical analysis. During the graphic analysis we did the univariate, bivariate and multivariate analysis, right? Then after that we checked the skewness, we checked the outliers,
We remove the skewness. We have not removed the outliers because the outliers was present in the categorical data. Then after that, we encoded the categorical data, right? Then we checked the multicollinearity. We applied the features, scaling methods. Then we removed the multicollinearity. We checked the class imbalance, and then after that, we balance the classes, right? You can also use the feature selection methods. You can use the feature importance methods, right? There are so many things can be done, right? Okay. Now, then after that, we are moving ahead for the modeling, means to build the models. We do not converted all object data type to float before scaling. We do not converted. Is it okay? Basically, I have converted whole data frame, means I have converted whole categorical data into the numerical data, right? So see, basically before building the model, okay, before building the model, you have to convert the categorical data into numerical data. Doesn't matter you are applying the scaling method only on the continuous column, and then after that you are applying you are converting the data into numerical data. It's up to you, okay? But before building the models, you have to convert the categorical data into the numerical data, otherwise you will get the error, okay? Also before balancing the classes, okay? Okay. Now, we are basically we are here again importing some libraries. You can also create your you can also write your own code to divide the data into train and test data. It is not mandatory to always use the sklearn libraries, right? Means scikit-learn. Okay, you can also use your own codes, right? Now, from sklearn dot model selection, we are importing the train test split. Then after that, from sklearn dot assemble, we are importing random forest classifier model. We are also sklearn from matrix. We are importing the accuracy score parameter because this is a classification algorithm, right? Now we are declaring two variables with the zero value, that is maximum accuracy, and the maximum random state, because we want to find out the maximum random state, right? So what we are doing here, we are using the for loop in the range of 1 to 200, and you can take any range. It is not mandated to take the range between 1 to 200. Clear? Then after that, here we are using the train test split method, and inside that we are passing the x1 and y1. X1 is basically the feature, okay, the features after applying the oversampling, and y1 is the target variable. The test size means we are using the 30% of the data for the test data and the 70% of the data for the training purpose. Random state is equal to y. Now the question is why we are using the random state, okay? See, basically whenever you are dividing the data is divided into several manners. Like here we are dividing the data into four parts: x train, x test, y train, y test. X train is basically a part of the independent feature which will be used to train your model. X test is basically again a part of the independent feature which we will pass to predict the future outcomes. Y train is basically the part of the target variable which will be used for the training purpose. Y test is basically is a part of the test data which will be used to check the performance of the model by comparing the prediction of the model, okay? So it means we are dividing the data into four parts: x train, y train, x test, and y test. Clear? Now whenever we are dividing the data, if we are not using the random state, then the data will be divided sequentially. If the data is divided sequentially, then definitely there will be a case where the target variable will not be, means for example, if for the in the 10,000 rows, in the first 800 rows only the yes value is there, and for the remaining value only the no is there, and you are dividing the data sequentially. In that case, in the 70 or 30 ratio, 80 or 820 ratio, and the data is divided sequentially, then your model will learn only about a particular single data frame, single data, okay? And just because it is sequential data, then your data will learn so many noise, so much, it will create so much biasness, right? So what we are doing, we are using the random state, because random state is using the random generator which will generate a random value, okay? Means it will select the sample of the data randomly for the X train and Y train, then for X test and Y test. Okay, in this way there will be no sequential data. Okay, your model will learn differently. Second thing is, once you divided the data, if you're not using the random state, every time you are using the X train and Y train, then the data will be changed and your model will not be able to calculate the performance, right? The performance will change. But whenever you are using the random state, then for each random value, a particular set of sample data, selected sample data will be fixed. Clear? Now, here, after dividing the data, we are using the random forest classifier to initiate it, right? And we are storing in the, after initializing, we are storing in the RFR variable, right? Then after that, we are fitting the model on the X train and Y train so that my model can learn about the training as well as for the test data. Sorry, it can learn about the independent feature and the target variable. After learning, we are using the same model to predict on the independent variable. Sorry, independent variable means X test. Now, these independent variables are basically unseen. Your model is aware about this data X train and Y train, but the model is basically totally unseen, or your model is not aware about the X test data. So when you are passing the RFR dot predict, then it will give the predictions. Okay, what can be the possible outcome for any set of any combination of input variables, because your model has learned about from X train and Y train. From the X train and Y train, what it has learned for a set of combination of the independent variable, what can be the possible outcome, right? So in the same way it will make the prediction. After making the prediction, we are using the accuracy score to find out the we are comparing the Y test. Y test means the original target variable for these values for X test and the prediction made by model. Okay, so the difference between the predicted value and the actual value is known as the accuracy. In simple terms, accuracy is known as the total number of correct predictions made by your model out of total predictions. Okay, the total number of correct predictions made by your model out of total predictions. Okay, it is known as the accuracy. Now what we are doing here, we are writing we are storing the accuracy in the ACC model, ACC variable. Then after that we are using the if parameter, and what we are writing, ACC if ACC is greater than max ACU, means if this value, if whatever the accuracy I am calculating here, if it is greater than the maximum accuracy, then we will store this accuracy in the max ACCU, okay, variable, and we will store the random state, means during the first iteration will be there, it will be stored in the max RS. So for example, during the first iteration, here the initial value is 0 0. During the first iteration, my model scored 60% of the accuracy, then 60% is greater than 0, correct? Then maximum accuracy will be updated with 60, and in the maximum random state, my first random state will be there. During the second iteration, my accuracy is only 58%, condition not satisfied, out of the loop. During the fifth iteration, for example, the accuracy is 60.5, again it is greater than 60, yes, then my maximum accuracy will be updated with 60.5, it will replace the 60. Then maximum random state will also be replaced, right? Earlier it was 1, now it will be 5, right? So it will check for the whole range here. You can take any range here, right? Now after that I'm printing here. So for the best accuracy at random state, means my best accuracy of the model is 86.79% at the random state 102. After the 102 till the 1999, okay, my accuracy has not crossed 86.79. Clear? How much time this code, how much time will this code take to run for 1 to 200 getting changed? So the time will be very large. So basically the time will be large, right? If you want to reduce the time, you can use the oops concept. Also you can change the values, right? Because the time consumption by the code, by the system to execute any code is basically depends on many factors. First one is your code, what is the code complexity, right? Time complexity means, right, whether you are using the functions, oops, concept, modularity or not, right? Second one is the algorithm you are using, how many input values are there, how many iterations are there. So basically the time complexity depends on different parameters, right? So you have to not only you should not think only about the range value, you should think about other parameters as well. Also the time complexity depends on the specification of your feature of your system. Clear? Okay. Now we are again creating the train and test, because during the doesn't matter what is the random state here, okay, in the maximum RS, what doesn't matter what is mentioned here, but the loop ends at 198 199 value. So if you check the I value, the last I value will be 199, right? So again we are dividing the data by using the maximum random state, means whatever the sample was selected for the maximum random state, it will be used to divide the data. Okay. After that, again we are importing the important libraries which we are going to use to check, to build and to check the performance of the model, right? So what we are doing here, we are again building the model for the random forest classifier, and we are using the same data. Again I'm saying we are using the same X train, X test, Y train, Y test for all the algorithms, right? First we are building a model by using the random forest classifier. Again we are checking, again we are making the predictions, we are checking the accuracy score, also we are checking the confusion matrix. I hope you know what is confusion matrix, right? Because in the confusion matrix, true positive, false positive, true negative, false negatives are there, right? Then after that we are also checking the classification report. Classification report is basically giving the a summary report of precision, recall, F1 score and support values. Clear? Okay. Now here you can see the accuracy has been decreased, that is 78.98. That can be a reason, right? Now here you can see the true positive, true negative, false positive, false negative. For the precision for the geo class is 0.84. For the first class it is 0.62. Recall value 0.89. Precision 1 is 0.5. F1 score, that is basically the harmonic mean of precision and recall. Here for the zero class is at 0.86, and it is supported by 1564 data points, means 64 rows. Then here the F1 score for one class is 0.56, and the data points supported, the number of rows supported 549. The overall accuracy is 0.79. Clear? That's fine. I'm not saying this is the final one. Okay, we can change it now, right? 78.98. Then after that we are creating one more model by using the logistic regression. We are again checking for the logistic regression, the accuracy is basically 80.5. That is basically quite, that is higher than the last model. Again here you can see the values for the confusion matrix has all changed, because it was 3091, it is 1400, 164, 248, 301. Then after that here the precision and the recall values has also changed. The accuracy is 0.81, means 81%, right? Or you can say 80.5 exact values there, right? Then after that, support vector machine, again we are using the SVC model to build the model for the support vector. Here you can see svc.fit x train y train, right? svc.predict x test. Then here accuracy is 79.93, right? Again the values are changed, here some values are there, right? So means we are building model for by using different algorithms. Why different algorithm? Because every algorithm has different functionality, different usage, right? Different advantages. So we cannot directly decide which algorithm will give the highest performance. So we have to build different models using different algorithms. We have to check the performance for each and every algorithms, right? Now for the gradient is gradient boosting, again it is 80.7, right? For ADA boost, again 80.97. Okay, that is basically greater than gradient descent, right? Then after that we are checking, also checking for the bagging classifier. For the bagging classifier it is 78.65. For exploratory classifier it is 78.12, right? So here we have checked that we have basically builded different models, and the accuracy is in range of 70 to 70 to 80%, right? That's fine, because in real life 70 to 80% accuracy is high, right? Now we have checked the accuracy, we have checked the performance of the model. Bagging is same as the random forest model, right? Basically it is not same. Okay, bagging is basically a technique. Okay, is a technique, and random forest algorithm is an example. Inside the bagging you can change the base estimator. Okay, but in the random forest model your base estimator is decision tree algorithm. I hope you are aware that, right? Because the random forest model is basically creating number of trees, number of decision trees. Okay, so random forest is a type, is an example, or is a type of your bagging classifier. Okay, where your base estimator is decision tree classifier. Clear? Okay, now basically we have scored accuracy, right? We have checked the confusion matrix, we have checked the precision, recall, F1 score. Now my question is, if I'm selecting the accuracy as my parameter to check the performance of my model, if my classes was not balanced, then in that case I would like to check F1 score, right? For medical cases, medical emergencies, for cancer cases, I will select recall as my parameter. But here I want to select the accuracy as my parameter. But now question is, whatever the accuracy you have received, 78%, 80%, 82%, 70%, right? How you are sure that whatever the accuracy you are getting for any model is accurate? Accurate means it is not affected by overfitting, not affected by biasness. How you are so sure that? Because we have not validated the accuracy, right? We have not validated the performance of the model. We are simply training the model on the data. Then after that, a test data is a part of the same data. We are doing the same thing. We are passing the data, but maybe your model is overfitting, right? So in that case, definitely you will see the there might be you are getting the highest accuracy, but in real life it is because of the overfitting, right? So what you need to do, just think about what you need to do. Basically we need to validate the performance of the model. But see, in real life, what if you are using the sklearn library, then definitely you can divide the data into two parts: training data and the test data. For the training data there are two files, xtrain and ytrain. For the test data, xtest and ytest. But in real life we divide the data into three parts. Okay, train data, test data, and validation data. Train data is used to train the model, okay, so that your model can learn about the data. Test data is used to check the performance of the model on the unseen data, and the validation data is used to check the performance of the model that you are getting on the test data. Okay, but here that is not the case. So there are some libraries that we are using, like cross validation methods. I hope you have heard about it. K-fold cross validation, LuCV, right? Then after that you have heard about cross val score method. Okay, these are the validation methods, okay, that are used to validate the performance of the model. So if I am selecting F1 score as my if I want to select F1 score to decide the performance of the model, then I have to cross validate it. If I'm selecting the precision, I have to cross validate the precision. Here I'm selecting the accuracy. Okay, so what do we need to do here? You need to validate the performance of the model by using the accuracy. So what I am doing, from sklearn dot model selection, import cross value score. Here I am selecting. Okay, first you need to understand what is the syntax for cross value score. You can also use different methods. I am using the cross value score. So basically in the cross value score, the syntax is cross value score, then model name, okay, for which algorithm you are going to check the performance. Features means x variable, target variable means y variable. CV is equal to fold value. CV is basically a parameter that is basically deciding the fold value, right? If I'm writing 5, then it means my data will be divided into 5 equal parts, and each part will hold randomly selected data. Okay, means my data is not dividing sequentially, it is dividing into 5 equal parts, and each part hold the random data, right? Randomly selected data. Now scoring is equal to accuracy, means which parameter you want to validate. If I want to validate the scoring, then I will check accuracy. Sorry, if I want to validate the accuracy, then here I will mention the scoring as the accuracy. If I want to select F1 score, I will select the F1 here, right? Now the the CV value has also one impact. If I am writing CV is equal to 10, it means my data will be divided into 10 equal parts. Okay, now the performance of my model will be checked 10 times, right? How it will be checked? So during the first iteration, it will take n minus 1, means n means 10. For example, my CV value is 10, then the n value is 10. N minus 1 will be used for the training purpose, and the 1 will be, means the 9 parts will be used for the training data, and the 1 part will be used for the test data, right? During the second iteration, the data which is already used for the testing data, it will be used for the training data, and any unused data will be used for the test data. Okay, for example, here 1 2 3 4 5 is there. So 1 2 3 4 5, during the first iteration 1 2 3 4 is used for the training, and the fifth is used for the test data. During the second iteration, maybe 1 2 3 and 5 is used for the training, and the fourth part is used for the test data. So once any part of the data is used for the test data, it cannot be used again. Okay, and for every part, your performance, your model will check the performance. Okay, now in the classification algorithm, default scoring parameter, if you are not mentioning the scoring parameter, then by default it will be accuracy. For regression, by default it will be R2 score or R squared. Clear? Okay, now we are checking the accuracy. We are checking the cross validation score. Score is equal to cross value score. Model name is RFC. X1 and Y1, that is basically X1 and Y1. If I'm not writing the CV value, then by default fold value is 5. I'm not mentioning the scoring parameter, then by default it is accuracy. Just because I'm checking the accuracy, then I'm not mentioning it, right? After that, I'm printing the score. So here you can see printing the score. Here you can see there are 5 values: 1, right, 2, then 3, then 4, and the 5. Why? Because my data is divided into 5 equal parts. My performance is checked 5 different times by considering different part as the test value, right? And then after that, it is taking the average of all these values, and that is basically the score dot mean, that is 85.25. Okay, then after that, I'm taking the difference between the accuracy and the cross validation score, and here the difference is basically negative 0.06. Okay, means what, why we are taking the difference? We are taking the difference between, because if you want to validate the performance of the model, if the difference between a particular parameter means accuracy here, and the cross validation score computed or calculated on the same parameter, like on scoring parameter accuracy, if the difference is less, it means the accuracy given by your model is accurate, is correct, and it is not affected by overfitting. Okay, if there is a more difference, it means there is a overfitting case. Clear? Now here we are checking for the GB, means for the gradient boosting, and here the difference is only negative 0.02. For the logistic regression, 0.03. For SVC, 0.006, that is basically very less, right? Means very less difference between the accuracy and the cross validation computed on accuracy. For AdaBoost, 0.04. For bagging classifier, 0.01, right? For the extra T classifier, 0.07. Basically for all the models, I'm getting the accuracy very less, very less difference between the accuracy and the cross validation computed on accuracy. So we can say that, okay, all the models are basically giving the accurate. Now we are quite impressed with the performance of our model, because the performance of the model is basically between the 75 to 80 or 85, right? That's fine. Now we are going to use the approach so that we can increase the performance of the model. And for that, what we are using, we are going to use the hyperparameter tuning. Okay, now hyperparameter tuning, I hope you have heard about it, right? So hyperparameter tuning is basically a kind of method. Okay, it's a kind of method which is used to increase the performance of the model by considering different parameters of the algorithm. Okay, different parameters, I'm saying different parameters of the algorithm. Clear? For every algorithm, there are different parameters. Just wait. Okay. Okay. See, here in the random forest model, if I'm checking the official website, simply search for, okay, simply search for sklearn.ensemble random forest class, directly search for random forest classifier sklearn, right? You will visit the official website. For example, here you can see sklearn. I checked for the random forest classifier. This is the official website, right? Here you can see there are different parameters like n estimator, criterion, what are the values, right? What are the possible value, what is the default value, maximum depth, minimum sample leaf, right? You can see all the parameter present for each algorithm, right? And based on that you can use it. Now I have also mentioned about the accuracy parameter, right? For the cross value score. So in the cross value score, here you can see the possible scoring parameter like accuracy, balance accuracy, top key accuracy, accurage, f1 score, f1 micro, weighted samples, negative, so many things. For clustering there are different parameters, for regression there are different parameters, right? Different scoring values, right? So in the same way here we are going to use the hyperparameter tuning, right? So that we can get the more generalized performance of our model for any particular algorithm, as well as to increase the performance of our model. Okay, so here you can see I'm using the hyperparameter tuning, and for that I'm using the grid search CV. Grid search CV is again a cross validation technique, but the difference is that the loose CV or the one k-fold or the cross value score that you are using, it is working based on the data, but the grid search CV or the randomized search CV is a cross validation technique which works based on the parameter and their values, mean parameter of the algorithms, okay, to decide the performance of the model. For every algorithm there are different parameters. For every parameter there are list of values, right? And for each value there is a different impact on the data, so we cannot directly decide which value should be used, right? For example, here it is taking the parameter for criteria. For example, just wait. For example, here I'm searching for extra tree classifier, right? Here extra tree classifier. Okay. Here you can see in the extra tree classifier and estimator, there are different parameters are there, right? So here first I'm selecting the n estimator, right? Just wait. I'm selecting the n estimators. You can see here n estimator. I'm taking the values, right? Then after that, for criteria, Gini, tropy, log loss, I'm using Gini and entropy, right? For log loss, there is a different case here. For maximum depth, minimum sample split, I am selecting maximum depth. Then after that, n jobs, right? So you need to select at least 5 parameters and with list of values, right? So here we are creating a parameters. Then after that, we are using grid search CV. Inside that, we are passing the algorithm name. Parameters, these are the parameters that we have decided. Then after that, CV is equal to 5. Here, that again, CV means full value, right? Now, what the grid search CV is doing, grid search CV is basically is creating a combination of the parameter and their values. The combination of the parameter of or their values where we are getting the maximum performance, it is giving as the best parameters, right? So for example, if you are using gsv.guest best parameter, then you will see the criterion is equal to Gini, max depth is equal to 10, n estimator is equal to 100, n jobs is equal to -2, random state is equal to 1000. Means these are the values for these parameters should be used when we will get the maximum accuracy. So for example, again, I'm building the model and here I'm writing criteria is equal to entropy. but here it is Gini, right? 10, 100, -2 and 50. Basically here I have changed two different parameters. First one is criteria, second one is randomity. So whenever you are changing the value, make sure that, for example, here I'm changing the value because I want to show you. Okay, if you are changing the value, make sure, okay, to use, first of all, for example, here I'm building a model, right? Okay. Now, here you can see, first of all, whenever you are building the model, okay, you are changing the values, you must have to show us, right? If we are changing the values, for example, here the Gini was giving the same accuracy, right? You can see the exact value. For the entropy, I'm also getting the same values. That's why I change the values, right? But this is not the case for every time. If I'm changing the values, then the performance will get affected, but here it was not changed. That's why I use the different parameter. So whenever if you are selecting any different parameter, make sure to show both the results so that we can identify whether any particular entropy, either particular parameter that you have changed is increasing the performance of the model or not. Clear? Clear? Okay, someone is saying please tell about bootstrap and oob score. What is oob score? Please let me know. Please let me know. Someone is asking about the OOB. Like, what is your understanding about the OOB? Because OOB is used for only for the random forest, right? And I'm not selecting for the extra tree classifier. I'm using the extra tree classifier, right? So you need to learn about this concept. I'm not going to teach you everything from the basic, right? So OOB is a different thing. OOB is basically used to find out the correctly predicted rows from the samples or from the overall data, right? So that we are not using here, but you can use, right? I have clearly mentioned that. Here I'm mentioning about the grid search saving, okay, because I want to increase the performance of the model. Okay, best performing model means the model that has the least difference between the between the selected parameter, scoring parameter, and the performance calculated on the same parameter. For example, here we have selected the extra T classifier because all the model is basically the difference between their accuracy and the cross validation is almost same, right? So that's why we are not selecting any we can select any one of them, but always select the model as the best performing model or the best model that has the least difference. Clear? Okay, done. Okay, then after that, here you can see 80.1312. If you check the previous extra tree classifier score, it was basically 78.18, right? But after the hyperparameter tuning, you can see here the now accuracy is 80.31. So basically this is the most generalized performance of my model. My the performance of my model has been increased. Clear? Okay. Now, someone was saying about the parameters. Someone was talking about whether we should learn about other libraries, right? Yeah or not. See, basically, I have mentioned that, right? You have to learn throughout your whole life. Why? Because every time you are changing. I hope you have learned about this algorithm because this code is basically shared by your mentor. Okay. I hope you have learned about this particular library to plot the ROC curve. Please let me know whether you have learned or not, whether your mentor has discussed this code or not. Someone is saying no, and most of you are saying yes. Okay. So basically this, yes, area under the curve. Okay. So basically, if your mentor has used this code, that is basically sklearn.matrix import plot ROC curve, or this one like in this way. So I want to inform you that this method has been deprecated. Okay. From the sklearn website, from the sklearn. Okay. If it is not because your mentor has shared the code, that's why I'm asking. Okay. If you're saying we used to plot the curve manually, again you can do that, right? If you are using, I think, another code, right? So I want to inform you that both the methods have been deprecated. I am not sure which method you are using for manually. You can calculate it manually, but I'm talking about the code that is basically shared by your mentor. This code, this particular plot ROC curve has been deprecated from the sklearn, right? Instead of that, they have used two new methods. First one is your ROC curve display. Okay, so just wait. See here, if I'm visiting the official website, right here you can see sklearn.matrix.plot ROC curve, and they have clearly mentioned that deprecated. Function plot ROC curve is deprecated in 1.0 and will be removed in 1.2 sklearn version, right? And they have introduced two new methods. First one is sklearn.matrix.roc curve display from predictions, and second is from estimator. Okay, these two methods are introduced by the sklearn, right? Okay, so basically we were taught the code to plot the ROC curve using the ROC AOC score manually. So basically the ROC AOC, you are saying this method is used to calculate the AOC value, right? I'm going to teach you. Just wait a minute. Okay, so basically here the whenever we are using the ROC curve, right, here there is one more method, that is matrix.roc curve. Inside that we are passing the y test and the prediction value, and it is calculating the FPR, that is basically false positive rate, true positive rate, and the threshold value. Because whenever we are making the graph, we are checking the AOC curve. Okay, basically there are two curve, okay, AOC and ROC. AOC is basically giving the value, right? That is basically 0.71, 0.9, 0.80. ROC is basically the curve that is basically representing. So if your AOC value is basically, well, now what is the AOC ROC? Basically it is used to find out whether your model is able to distinguish between the classes being the unique values, whether it is able to identify or not. If the AOC value is closer to 1, then it means your model is able to distinguish between the classes. But if it is less than 0.7, or then in that case it is not able. If it is 0.5, then it means your model is like 50% chance. If it is less than 0.5, then your model is performing worst. Okay, so here what we are doing here, first we are selecting the FPR TPR, then after that we are using matrix.AOC to calculate the FPR and TPR. Okay, FPR and the TPR, sorry, based on the FPR and TPR we are calculating the AOC value, and we are storing in the ROC AOC. Then after that we are using matrix.roc curve display, and here what we are doing here, for the FPR parameter, there is one FPR parameter, we are using this value that we have calculated. For the TPR we are calculating the TPR. For ROC we are sharing the AOC value that we have calculated. Estimator name means your model name. Okay, your my final model is basically this one. This one, I have given this model name as the final model name, right? Then after that, when you are checking this one, then here you are saying the extractive classifier with criteria entropy, because I have selected the entropy at that time. Max that is equal 10, all the parameters there, and the AUC value 0.71, right? And so we have mentioned that here we have plotted the ROC curve for the final model, and the AUC value for the best model is 71%. Clear? Okay. Now after that, after doing all the things, now you need to save the model, right? And to save the model, you can use the two methods. First one is joblib, second one is pickle method, right? So what we are doing here, we are using the joblib method, and we always save the best performing model, right? So here we are using the dump method so that we can serialize our model, means we can convert in a binary format so that we can store the values. Then joblib.dump, then here we are mentioning the final model because we are saving our final model, means the model which we have created after the hyperparameter tuning. Then after that we are giving the file .pkl. Pkl is basically representing the pickle file, right? Then after that we have saved the model, right? You will see this file in your destination folder. Clear? If you want to use the file in the in future, or you want to share the file with someone and they want to use, then they need to use model is equal to joblib.load method. Okay, this load method is basically load, this means to deserialize the model. Okay, and you need to pass the file name. After that, here I'm storing in the model, and when I'm using the model.predict and I'm passing the x test, means the unseen data, it is making some predictions, right? To know about the predictions, whether the predictions made by your model is correct or not, you can create an array and you can compare the value. Like here we are doing, here we are first converting the y test into array and storing it a variable. Then after that we are creating a data frame, and uh what we are storing both, means your predicted value and the original value. And predicted value is basically here the prediction, right? And the original value is basically a variable. And here you can see, for the 0 index, the predicted value by your model is 1, the original value was 1, means predictions are correct. For the second model, for the first index, the predicted value was 0, whereas the original value was 1, then the prediction is wrong. For the third, 0 0 0 1 0 0 0 0 0 0, means that's why you are getting the 80% of the accuracy. Okay, so basically that is all about today. Okay, we had discussed so many things about a classifier model. I hope you have learned so many things, right? The session was basically for 3 hours, but I have already taken more than 4 hours, right? And I'm really sorry for that, but I hope uh, I have utilized this time to teach you more about the different library, different aspect of the projects, right? Which you can use to complete the future projects, right? Okay, now this is all about today. Now I'm going to share the link, right? I'm not okay, I'm going to share the link. Okay, you can just go through the link, you can use the same link, right, to read the data. But I am not going to share my Jupyter notebook. Again, I'm saying I'm not going to share the Jupyter notebook, because I know most of you will copy paste the code and will execute it, right? I want you to get hands-on practice, right? Hands-on experience. And for that, you have to write down the code by watching the recorded video, which I'm going to share with your institute. Clear? Okay, now just wait. Just wait a minute. Okay, I'm just sharing the data. Okay, so basically, for example, this is our data set, right? If I'm sharing the GitHub link, then you will see this data set, right? This data set you will see here. What you need to do, I'm just sharing this GitHub link, okay, with everyone. Okay. So today's recording will be available from tomorrow. Yeah, by tomorrow morning. Okay, it will be available on your on the forum used by your institute, right? Yes, we will share the recording of this video. Okay, I hope you have received the GitHub link, right? But if you are sharing, if you are using this GitHub link directly, I'm saying, if you are using this GitHub link to read the dataset, for example, here I'm writing, right? Then you will get an error. Please remember that. Okay, whatever the link I have shared, if you are using this link to read the data by using the pd.read csv, you will get the error. Why? Because here you are directly sharing the link, but I have clearly mentioned that you need to use the raw link of the file. For that, what you need to do, here you can see there is an option of raw. Simply click there. Okay, again you will be redirected to this page. Copy the link of this page. Okay, and now pass this link here instead of the normal GitHub link, and you will be able to see the output. Clear? Clear? Please let me know as soon as possible so that I can wrap up this session. Okay, great. Now, I hope you have received the GitHub link, right? Please use this GitHub link to read the data from the website, from the GitHub, right? Watch the recorded video and practice whatever I have discussed in today's session. Okay, in your Jupyter notebook, you have whole 1 week, because I'm going to conduct a session next Sunday. So you have whole 1 week to learn, to practice whatever I have discussed today and whatever covered by your institute. Clear? Okay, so that's it for the today. Thank you everyone for the session, for joining the session. Okay, and please revise everything before starting the practice project. Clear? Okay.